Imagine standing at the edge of the universe, where time stretches beyond comprehension and stars are born and die in silence. Older than memory, everything we know, every thought, every dream, flickers against the vast cosmic expanse. The galaxies swirl, dark matter hums invisibly, and black holes hold secrets that challenge our understanding of reality itself. Yet here we are, fragile, conscious, alive, capable of gazing into the infinite and asking questions that may never have answers. Our curiosity, our wonder, and our desire to explore are echoes of the universe within us. Each choice, each moment of reflection reverberates against the backdrop of existence, connecting the human mind to the cosmos in ways both subtle and profound. What does it mean to exist in a universe so immense, so indifferent, yet so breathtakingly beautiful? How does the vastness of space shape our understanding of ourselves, our purpose, and our potential? This is more than science. It is a journey into the heart of reality, where the infinite meets the intimate, where the mysteries of the cosmos awaken the deepest parts of the human spirit. The universe is waiting, and so are we. 1. The cosmic perspective. How the universe shapes human curiosity. When we lift our gaze to the night sky, we are confronted with a vision that is at once familiar and incomprehensible. The stars, scattered across the darkness, are both markers of place and signposts of possibility. For centuries, humans have stood beneath this celestial tapestry, wondering not just what lies beyond, but what it means to exist within the grand theater of the cosmos. The cosmic perspective is more than a mere observational stance. It is a profound shift in consciousness, a lens that reshapes our understanding of ourselves, our ambitions, and the very nature of curiosity itself. It challenges us to confront both the immensity of the universe and the minuteness of our individual lives, and yet, paradoxically, it ignites a drive to explore, to question, and to imagine. The universe, in its infinite complexity, does not yield its secrets easily. From the earliest astronomers charting the predictable paths of planets, to modern astrophysicists probing the depths of black holes, human curiosity has been the catalyst for every leap of understanding. Curiosity, in this context, is not simply a desire to accumulate knowledge. It is the force that compels us to stretch beyond the boundaries of our immediate perception. The cosmic perspective amplifies this drive. When we comprehend the scale of the universe, its billions of galaxies, each containing billions of stars, some hosting planets in potentially habitable zones, we begin to see that human questions are necessarily profound, that our speculations about life, time, and existence are not idle musings, but essential responses to the universe's grandeur. Consider for a moment the sheer scale of the cosmos. Light from the nearest star beyond our sun, Proxima Centauri, takes over 4 years to reach Earth. The Andromeda Galaxy, our nearest galactic neighbor, lies more than 2 million light-years away. Each of these numbers, each measurement, is not merely a statistic. It is a testament to the mind's ability to transcend immediate experience, to imagine distances and durations far beyond our daily comprehension. The cosmic perspective insists that we stretch our minds to think in scales of time and space that are almost absurdly large, and in doing so, it cultivates humility. Yet within that humility lies a spark of exhilaration. If we, a species confined to a small planet in a small solar system, can begin to map and understand such vastness, what might we yet discover? This perspective also reshapes the way we perceive time. In the cosmic frame, the human lifespan becomes a fleeting blink against the eons over which stars are born and die. Galaxies collide, and black holes silently consume light and matter. And yet, this recognition does not diminish our significance. Rather, it frames our curiosity as a remarkable product of evolution. On a tiny, rotating rock in a quiet corner of the Milky Way, life emerged that could reflect upon itself, that could measure, theorize, and dream. Our curiosity is the universe contemplating itself through our consciousness. The cosmos, in a sense, has produced a mind capable of asking questions it may never fully answer, and this realization inspires a profound sense of wonder. The history of human thought is inseparable from the history of this cosmic curiosity. Ancient civilizations, from the Babylonians and Egyptians to the Maya and Chinese, looked to the stars to understand cycles of life, death, and the passage of time. They charted constellations, constructed observatories, and created elaborate calendars, all attempts to decode the universe's rhythms. These early efforts demonstrate a remarkable trait. Humans instinctively recognize patterns, seek order in apparent chaos, and strive to find meaning in the cosmic theater. The act of mapping the heavens was not just a scientific pursuit, it was a philosophical and spiritual endeavor, an acknowledgement that our fates are intertwined with the wider universe. As our tools of observation have grown more sophisticated, so too has the scope of our curiosity. Telescopes that peer across the electromagnetic spectrum reveal galaxies forming in the early universe, cosmic jets traveling millions of light years, and the subtle warping of space-time predicted by Einstein. Space probes have journeyed to the edges of our solar system, sending back data from worlds we can scarcely imagine. Each discovery expands our awareness and reshapes our questions. Are we alone? What is the ultimate fate of the universe? How does consciousness arise in a universe governed by physical laws? The cosmic perspective constantly reframes our understanding, forcing us to revisit assumptions and inspiring the next generation of explorers, theorists, and dreamers. Yet, curiosity is not merely a cognitive pursuit. It is deeply emotional, motivational, and even existential. To confront the universe is to confront ourselves, to wrestle with our limitations and our aspirations. In the vastness of space, we experience a mixture of insignificance and empowerment. We are reminded of our mortality, yet also of our capacity for imagination, resilience, and innovation. The stars do not speak directly, yet through the language of mathematics, physics, and observation, they narrate stories of creation, transformation, and destruction. The human mind, in turn, interprets these stories, weaving them into frameworks of understanding that extend from the philosophical to the practical, from the poetic to the scientific. The cosmic perspective also encourages a re-evaluation of human priorities. In a world often consumed by parochial concerns, political struggles, and fleeting ambitions, the contemplation of the universe invites a form of intellectual and emotional recalibration. When we recognize the fragility of our planet, the improbability of life, and the scale of cosmic time, our perspective shifts. Questions about ethics, cooperation, and stewardship acquire a new urgency. Curiosity, in this sense, is inseparable from responsibility. To understand the universe is not only to expand our knowledge, but to guide our actions in ways that honor the singularity of life on Earth, even as we dream of extending our reach to the stars. In exploring the cosmic perspective, we also confront the limits of human perception. We are, after all, creatures of a narrow sensory and temporal window. Our eyes perceive only a fraction of the electromagnetic spectrum. Our lives occupy but an instant on cosmic timescales. And yet, through ingenuity and imagination, we transcend these limitations. Instruments allow us to detect gamma rays from distant quasars, to measure the faint whispers of gravitational waves from colliding black holes, and to chart the cosmic microwave background, the afterglow of the Big Bang itself. These achievements illustrate a fundamental truth. Curiosity is the engine that transforms limitation into discovery. The universe does not conform to human scales, yet our minds persist in reaching toward it, continually redefining the boundaries of understanding. This pursuit is not without its mysteries and paradoxes. The universe presents phenomena that defy intuition, such as quantum entanglement, dark matter, and the apparent acceleration of cosmic expansion. These enigmas provoke not frustration alone, but profound engagement. They compel us to develop new mathematics, new philosophies, and new ways of conceptualizing reality. Curiosity, fueled by the cosmic perspective, becomes a dynamic interplay between wonder and rigor, between imagination and discipline. It is a dialogue in which the universe, silent yet eloquent, continually challenges the boundaries of what we know and what we dare to think. Moreover, The cosmic perspective cultivates a profound sense of connection. While the universe is vast and indifferent to human concerns, it is also the common ground for all life on Earth. Every atom in our bodies was forged in the hearts of ancient stars. The elements that compose our world and our very cells have traveled across cosmic distances and epochs to converge here on this small planet at this precise moment. To embrace the cosmic perspective is to recognize that we are part of a vast continuum, a lineage that stretches across billions of years and unimaginable distances. Curiosity, then, is not merely an individual pursuit, but a shared human endeavor, linking us to one another and to the universe itself. This perspective also shapes our aspirations in profound ways. Human exploration, from the first telescope to interplanetary missions, is motivated not solely by practical objectives, but by the desire to witness, to experience, and to understand. The dream of setting foot on other worlds, of observing distant galaxies up close, and of uncovering the fundamental laws of nature, is rooted in the same curiosity that compels us to look up at the stars. The universe, in its immensity, acts as both challenge and inspiration, a mirror reflecting our deepest desires to know and to expand the horizon of possibility. Ultimately, the cosmic perspective transforms curiosity from a personal trait into a guiding principle for our species. It teaches us patience, for understanding unfolds across generations. It teaches us humility, for our place in the universe is simultaneously infinitesimal and extraordinary. And it teaches us resilience, for the pursuit of knowledge is seldom straightforward, often demanding the courage to confront uncertainty and the unknown. Curiosity, illuminated by the cosmic perspective, becomes a bridge between the human mind and the universe, a bridge constructed from imagination, observation, and the enduring quest to make sense of the infinite. In this light, human curiosity is not a mere byproduct of survival or utility. It is an essential expression of our species' engagement with reality. The cosmos, indifferent yet magnificent, provokes in us a drive that is uniquely human, to explore, to question, to imagine, and to seek understanding in the face of overwhelming scale and complexity. Every observation, every theory, and every daring hypothesis is a manifestation of this cosmic dialogue, and as we expand our gaze beyond the confines of our planet, probing the dark corners of space and time, we recognize that curiosity is not merely about answers. It is about the profound, transformative act of asking questions in the first place. The night sky, with its endless stars, reminds us that the universe is not a static backdrop, but a dynamic, evolving entity. Galaxies swirl, stars ignite and fade, and black holes reshape space-time itself. In witnessing these processes, human curiosity finds both a canvas and a compass, a framework for understanding not only the cosmos, but the nature of inquiry, imagination, and discovery. To adopt the cosmic perspective is to embrace a lifelong journey of wonder, a commitment to seeing beyond the familiar, and a recognition that in seeking to understand the universe, we also uncover the deepest truths about ourselves. And so, as we consider how the universe shapes human curiosity, we come to see that this is more than an intellectual pursuit. It is an existential dialogue between mind and cosmos, a dynamic interplay that challenges us to expand the limits of thought while deepening our connection to the world around us. The cosmic perspective urges us to think expansively, to act boldly, and to cherish the irreducible mystery that lies at the heart of existence. In the vast theater of the universe, curiosity becomes both our guide and our companion, illuminating paths of understanding that stretch far beyond the boundaries of imagination, yet always rooted in the singular, wondrous fact that we, a species of fleeting lives, have the capacity to wonder at the stars. This is the perspective that has driven humanity from the earliest constellations etched on cave walls to the most sophisticated telescopes orbiting above our atmosphere. It is a perspective that compels us to ask questions that may never have definitive answers, to challenge assumptions, and to pursue knowledge with both rigor and reverence. The universe, in its immensity, shapes our curiosity not by providing easy answers, but by presenting enigmas that demand creativity, perseverance, and an unyielding spirit of inquiry. To embrace the cosmic perspective is to accept that the universe is both a teacher and a mirror, a reflection of our deepest yearnings to understand, to explore, and to find meaning within the infinite. As we continue to push the boundaries of discovery, we find that human curiosity, illuminated by the cosmos, is inexhaustible. Each new observation opens doors to further questions. Each theoretical insight reveals new mysteries. The stars, the galaxies, the unseen forces of dark matter and energy all beckon us toward exploration, reminding us that the journey of understanding is unending. In this endless pursuit, the cosmic perspective becomes both inspiration and imperative. To look outward is to look inward. To seek knowledge is to seek connection. And to confront the vastness of the universe is to confront the boundless potential of the human mind. 2. Black holes and the limits of knowledge. Black holes are perhaps the most enigmatic objects in the cosmos. Regions where the known laws of physics themselves seem to falter, where space and time collapse into singularity, and where human imagination is stretched to its limits. They are not merely cosmic curiosities. They are profound provocateurs of thought, challenging our deepest assumptions about reality, knowledge, and the nature of existence itself. To contemplate a black hole is to confront the boundaries of understanding, to grapple with the interface between what we can observe and what may forever remain beyond comprehension. In this confrontation, the human mind encounters both the limitations and the extraordinary potential of curiosity. From the earliest theoretical musings of John Michel and Pierre-Simon Laplace in the 18th century, to Einstein's revolutionary insights into the curvature of space-time, black holes have existed in human thought long before we could detect them. Initially, they were mathematical abstractions, peculiar solutions to the equations of general relativity, almost like intellectual phantoms conjured by the geometry of space and time. Yet, as our tools of observation evolved, these theoretical constructs transformed into tangible objects of study. With evidence mounting through the detection of stellar motions, gravitational lensing, and the extraordinary emission of X-rays from the accretion disks of matter spiraling toward oblivion, black holes, once theoretical curiosities, became undeniable participants in the cosmic narrative, simultaneously terrifying and captivating in their inscrutable power. What makes black holes so compelling is not simply their gravitational dominance, but their radical challenge to our understanding of causality and knowledge. In the vicinity of a black hole, space and time behave in ways that are counterintuitive. The closer one approaches the event horizon, the boundary beyond which nothing, not even light, can escape, the more time itself seems to dilate. From an external observer's perspective, objects appear to freeze at the edge, while the traveler crossing the horizon experiences time differently, inexorably drawn toward the singularity. This relativistic distortion of time forces us to question the very notion of temporality as an absolute concept. If time itself is malleable, what does that mean for the human perception of cause and effect, for the narratives we construct about past, present, and future? Moreover, black holes embody the ultimate limits of observation. No telescope, no detector, no instrument can directly perceive the singularity at their core, where density becomes infinite and known physics collapses. We can infer their presence by their gravitational influence, by the radiation emitted as matter accelerates and disintegrates near the event horizon, and more recently by capturing the shadow of a supermassive black hole through the Event Horizon Telescope. Yet, despite these remarkable achievements, the singularity remains an impenetrable veil, a cosmic reminder that there are realms of reality forever beyond empirical scrutiny. This is both humbling and inspiring. It reminds us that knowledge is not merely a matter of effort or ingenuity, it is constrained by the fundamental structure of the universe. And in acknowledging these limits, human curiosity is both sharpened and ennobled. The study of black holes has also revolutionized our understanding of information, entropy, and the nature of reality itself. Stephen Hawking's insight into black hole thermodynamics revealed that these cosmic maelstroms are not merely gravitational sinks, but also possess entropy and emit radiation, now known as Hawking radiation. This discovery bridged the realms of general relativity and quantum mechanics, two pillars of modern physics that often appear in conflict. It suggested that information swallowed by black holes is not destroyed, but encoded in subtle, almost imperceptible ways, challenging our intuitive notions of permanence, loss, and determinism. The black hole becomes a philosophical mirror, reflecting our assumptions about certainty, predictability, and the limits of human comprehension. Black holes also provoke existential reflection. In contemplating a singularity, we are confronted with a phenomenon that simultaneously annihilates matter and transcends human understanding. We are reminded that the universe is not obligated to conform to human logic or convenience. Its mysteries are not puzzles designed to be solved, but expressions of a reality that is indifferent, vast, and sometimes inaccessible. And yet, it is precisely this confrontation with the unknowable that ignites wonder. Our species is drawn not only to what can be understood, but to what challenges our understanding most profoundly. Black holes are, in a sense, the ultimate playground for human imagination, a place where the edges of mathematics, physics, and philosophy converge. The implications of black holes extend beyond astrophysics into the very way we conceptualize existence. If space and time are relative, if singularities disrupt our understanding of causality, if information may be preserved in forms we cannot yet decode, then the universe is not merely a stage for events, but a dynamic, layered reality that exceeds our capacity for complete comprehension. This realization resonates with broader philosophical questions. What does it mean to know? How does consciousness interpret reality? Can the limits of empirical observation illuminate truths about the nature of existence itself? In these questions, black holes serve as a bridge between science and philosophy, between observation and speculation, between the empirical and the profoundly abstract. The emotional dimension of contemplating black holes is as significant as the intellectual. They evoke awe, fear, and a sense of sublime beauty. To imagine a star collapsing under its own gravity, to witness the bending of light around an invisible mass, to recognize the event horizon as a point of no return, evokes an emotional response that mirrors the scale and power of the phenomena themselves. This blend of rational understanding and emotional resonance is a hallmark of human engagement with the cosmos. It demonstrates that curiosity is not merely cognitive, but deeply affective, motivating exploration, innovation, and creative thought. The black hole also serves as a metaphor for human limits and aspirations. It is a reminder that while knowledge can be expanded endlessly, there are frontiers that may forever elude direct perception. And yet, in confronting these frontiers, we discover new ways of thinking, new mathematical tools, new technologies, and new philosophical frameworks. In this way, the limits imposed by black holes do not constrain human creativity. They amplify it. They compel us to imagine, to theorize, to model, and to probe reality in ways that extend far beyond ordinary experience. In grappling with the unfathomable, we find the essence of what it means to be human, the drive to understand, even in the face of uncertainty and impossibility. Modern astrophysics has taken these inquiries to extraordinary levels. The study of supermassive black holes at the centers of galaxies has revealed their role in shaping cosmic evolution. Their immense gravity influences star formation, galactic structure, and the distribution of matter across billions of light years. Stellar mass black holes, remnants of massive stars, punctuate the fabric of space with their gravitational influence, creating binary systems, emitting X-rays, and occasionally merging in violent collisions that ripple across space-time as gravitational waves. Each observation enriches our understanding, not only of these extraordinary objects, but of the universe as a coherent, interconnected system. Curiosity about black holes is thus inseparable from curiosity about the cosmos as a whole. To study them is to study the architecture of reality itself. Black holes also push the boundaries of human imagination in ways that transcend physics. Science fiction has long drawn upon their mysterious and dramatic qualities, from Kip Thorne's rigorous theoretical frameworks to speculative narratives exploring time travel, alternate realities, and the ultimate fate of consciousness. These stories, while fictional, reflect a deep engagement with the same questions that motivate scientific inquiry. They illustrate that human curiosity is not confined to empirical observation alone, but encompasses narrative, metaphor, and creative speculation. Black holes, in this sense, are both scientific objects and symbols, representing the frontier where knowledge ends and imagination begins. Furthermore, black holes invite reflection on the nature of observation itself. They challenge the notion that reality is fully accessible, reminding us that much of what exists may be hidden or only partially revealed. This has profound implications for epistemology, the study of knowledge. If even the most extreme, tangible features of the universe, those that bend light, warp time, and shape galaxies, can be partially concealed from direct observation, then the pursuit of understanding is inherently provisional. Science becomes not a repository of final truths, but a method of engagement, a way of interacting with reality that acknowledges both what can be known and what may remain forever inaccessible. In this light, curiosity is as much about navigating uncertainty as it is about acquiring facts. The singularity at the heart of a black hole exemplifies this principle. It is a point where density becomes infinite and the known laws of physics break down. It represents the ultimate epistemic horizon, a place where the equations that describe the universe cease to function in familiar ways. Yet, the very existence of this boundary challenges us to refine our theories, to develop new mathematics, and to explore the interplay between general relativity and quantum mechanics. In confronting the singularity, we confront the limits of human reasoning and the potential for conceptual innovation. Black holes thus serve as catalysts for intellectual growth, pushing the boundaries of what it means to know, to imagine, and to theorize. The study of black holes also illuminates the interplay between observation and abstraction. While no light escapes their core, the indirect effects of black holes, gravitational lensing, orbital dynamics, and radiation from accretion disks, allow scientists to infer their properties with remarkable precision. This demonstrates a profound lesson about the nature of knowledge. We rarely, if ever, access reality directly. Instead, understanding emerges through careful interpretation, inference, and modeling. Human curiosity, in this sense, is a creative act, a process of constructing insight from incomplete data, of reaching toward the invisible with reason and imagination. Black holes, more than any other cosmic phenomenon, embody this dialectic between the seen and the unseen, the known and the unknowable. Moreover, black holes compel us to question the very nature of existence. If space and time can be warped, if information can be encoded in ways we barely understand, if singularities can exist as points of infinite density, then our intuitive grasp of reality is provisional. The universe is stranger than we imagine, and yet it is precisely this strangeness that inspires exploration. In the face of the unknowable, human curiosity becomes an ethical as well as intellectual endeavor. To seek understanding responsibly, to confront uncertainty with rigor and humility, and to celebrate the capacity for insight even when complete knowledge remains forever out of reach. In contemplating black holes, we also confront the paradox of permanence and impermanence. These objects, formed from the collapse of massive stars, endure across eons, shaping galaxies and influencing cosmic evolution. Yet they are themselves subject to change through phenomena like Hawking radiation. They embody the tension between stability and transformation, between the predictable and the mysterious. Human curiosity, in response, must navigate this tension, recognizing that understanding is always provisional, yet striving nonetheless to illuminate the darkness, to map the contours of reality, and to expand the horizons of possibility. Ultimately, black holes remind us that the pursuit of knowledge is both a privilege and a responsibility. They are cosmic teachers, challenging us to think rigorously, to question assumptions, and to embrace uncertainty with courage and creativity. They reveal the limits of perception, the malleability of time and space, and the intricate interplay between observation, theory, and imagination. In doing so, they inspire a profound sense of humility and wonder, inviting us to recognize that, while the universe may be vast, complex, and partially unknowable, the human mind possesses the remarkable capacity to reach, to question, and to explore. Black holes, then, are more than astronomical objects. They are touchstones for human thought, catalysts for philosophical reflection, and engines of curiosity. They embody the ultimate challenge to knowledge. Yet in confronting that challenge, we find the essence of scientific endeavor, the persistent, imaginative, and rigorous engagement with reality, no matter how formidable, no matter how elusive. To study black holes is to embrace both the exhilaration and the limits of human understanding, to navigate the edge between the known and the unknowable, and to participate in a cosmic dialogue that transcends time, space, and the ordinary bounds of perception. In the final analysis, black holes compel us to reconsider not only what we know about the universe, but what it means to know at all. They illustrate that the pursuit of understanding is as much about asking the right questions as it is about finding answers. That curiosity flourishes, not in certainty, but in the presence of profound mystery. They reveal that the universe is at once comprehensible and elusive, that the boundaries of knowledge are not barriers to imagination, but invitations to deeper inquiry. And in embracing these invitations, we affirm a fundamental truth, that the human spirit, driven by curiosity, possesses an extraordinary capacity to explore, to wonder, and to engage with the vast, mysterious, and awe-inspiring cosmos in which we are privileged to exist. 3. Dark matter. Invisible forces. Visible impacts on thought. In the vast expanse of the universe, what we can see, the stars, planets, galaxies, nebula, represents only a fraction of the cosmic story. What remains unseen is far more mysterious, far more pervasive, and far more influential than the light that dazzles our eyes. This hidden majority of the cosmos is what we call dark matter, an invisible substance that neither emits nor absorbs light, yet whose presence is inferred through the gravitational influence it exerts on the visible universe. Dark matter constitutes approximately 27% of the total mass energy content of the cosmos, dwarfing the ordinary matter that forms everything from atoms to galaxies. Its invisibility is both literal and metaphorical, challenging our capacity to perceive, comprehend, and integrate knowledge about the universe, and in doing so, reshaping the way we think about reality itself. The existence of dark matter was first hinted at nearly a century ago, through careful observations of galactic rotation. In the 1930s, astronomer Fritz Zwicky measured the velocities of galaxies within the Coma cluster and noticed a discrepancy. The galaxies moved far faster than could be accounted for by the gravitational pull of visible matter alone. There had to be something unseen, something exerting gravitational influence yet escaping detection by every conventional observational tool. It was a startling revelation, suggesting that the universe harbors hidden forces far beyond ordinary perception. This was not merely an astrophysical curiosity, it was a conceptual revolution, a radical reminder that what we observe directly may represent only a fraction of reality, and that the most fundamental truths often lie beneath the surface, invisible yet potent. Dark matter's invisibility forces us to confront the limits of human perception and the provisional nature of knowledge. Our senses, refined through millions of years of evolution, attuned to detect patterns and objects within familiar scales, what we can see, touch, hear, and measure in everyday life. Yet the cosmos operates on scales and through mechanisms far beyond our intuitive grasp. To understand dark matter, we must extend our minds with abstraction, mathematics, and inference, constructing a model of reality that accommodates the unseen. This is not merely a technical exercise, it is a profound cognitive challenge, one that illuminates the extraordinary capacity of the human mind to reason about phenomena that cannot be directly perceived, to engage with the invisible, and to allow the intangible to shape our understanding of existence. The implications of dark matter are profound, not only for astrophysics, but for philosophy, cosmology, and even psychology. Consider the structure of galaxies. Without dark matter, the swirling disks of stars would tear themselves apart. The gravitational scaffolding, provided by this unseen mass, is essential for the formation and stability of galaxies, for the evolution of stars, and ultimately for the emergence of planetary systems capable of supporting life. In this sense, dark matter is a silent architect of cosmic order, an invisible hand shaping the trajectories of worlds and the destiny of civilizations. The universe, it seems, relies as much on the unseen as on the visible, and in contemplating this reality, we begin to recognize that human understanding is invariably partial, provisional, and conditioned by the limits of perception. The pursuit of dark matter has also expanded our understanding of scientific method, epistemology, and the interplay between observation and theory. Unlike stars or planets, dark matter cannot be detected directly through electromagnetic radiation. Scientists must rely on indirect effects, gravitational lensing, the motions of galaxies, and the cosmic microwave background, the afterglow of the Big Bang. Each of these measurements requires careful interpretation, sophisticated modeling, and the synthesis of multiple lines of evidence. Here, curiosity takes a distinctive form. It is an engagement with absence, a quest to infer presence from influence, to reason about what cannot be touched, seen, or measured directly. This is an extraordinary intellectual achievement, revealing that human knowledge is not simply about accumulation of data, but about the creative, imaginative, and disciplined interpretation of what lies hidden. Dark matter also challenges our metaphors, our language, and our conceptual frameworks. It defies direct sensory experience and demands that we think beyond intuition, beyond the ordinary, and beyond the familiar. We speak of it as dark because it eludes light, but the term itself is inadequate. It is more than darkness. It is an entire invisible architecture of reality, shaping galaxies, clusters, and the cosmic web. In contemplating dark matter, we confront the profound truth that what is invisible can be as real, as consequential, and as structurally essential as what we can see. The human mind, conditioned to equate visibility with reality, must stretch to grasp a universe in which presence is not synonymous with appearance, in which influence precedes perception, and in which the unseen may be the most significant actor in the cosmic drama. This confrontation with invisibility resonates beyond science, influencing human thought, philosophy, and even our emotional life. Dark matter teaches humility, reminding us that perception is limited, and that reality is far richer and stranger than the immediate evidence before us. It inspires imagination, prompting us to conceive of a universe populated by forces and structures that escape our senses, yet determine the evolution of galaxies, stars, and planets. It challenges certainty, encouraging a mindset in which questions are valued as much as answers, where the unknown is not a void to be feared, but a frontier to be explored. In this way, dark matter is both an empirical reality and a metaphor for the unseen forces that shape human life, cultural, psychological, ethical, and spiritual, inviting reflection on the interplay between the visible and the invisible in our own existence. The search for dark matter has also spurred technological and methodological innovations of unprecedented scope. Deep underground laboratories, shielded from cosmic radiation, host experiments designed to detect the faintest interactions between hypothetical dark matter particles and ordinary matter. Cryogenic detectors operate at temperatures near absolute zero, measuring infinitesimal energy transfers that may betray the presence of elusive particles. Space-based observatories track the subtle gravitational lensing of distant galaxies, mapping the distribution of dark matter across the cosmos. Each of these endeavors represents a triumph of human ingenuity, a testament to our capacity to design instruments capable of interacting with the universe in ways that surpass direct sensory experience. Curiosity in this context becomes an engineering and conceptual feat, a translation of wonder into experimental practice. Moreover, dark matter challenges our understanding of causality and determinism. The structures it forms, the patterns it influences, and the gravitational scaffolding it provides are invisible, yet decisive. Galaxies, solar systems, and even the environments conducive to life are profoundly shaped by forces we cannot directly perceive. This realization encourages a broader philosophical reflection. The universe may be structured by influences beyond our immediate perception, and our understanding of causality must extend to include not only what we see but what we infer. In this sense, dark matter becomes a guide for thinking about complexity, emergence, and the limits of intuition. It reminds us that reality is multidimensional, layered, and often mediated by factors that are hidden from direct observation. Dark matter also invites reflection on the interplay between theory and observation. Its existence was first inferred from anomalies in galactic motion. Yet, the quest to understand its nature has led to a multiplicity of theoretical candidates. Weakly interacting massive particles, accents, sterile neutrinos, and even modifications of gravitational theory itself. Each hypothesis represents an imaginative attempt to reconcile observation with understanding, a testament to the interplay between empirical evidence and creative reasoning. The human mind, confronted with an invisible yet undeniably influential presence, must navigate ambiguity, construct models, and iteratively refine them in light of new data. This iterative process of conjecture, testing, and refinement exemplifies the dynamic, self-correcting nature of scientific inquiry driven by curiosity, rigor, and imagination. The emotional and existential dimensions of dark matter are equally compelling. To recognize that the majority of the universe consists of a substance that eludes our direct perception is to confront a profound, humbling truth that human experience is constrained, that our immediate understanding of reality is partial, and that the cosmos is vastly more intricate than our senses reveal. Yet this recognition is not disempowering, it is invigorating. It transforms curiosity into a journey of exploration, a deliberate engagement with the unseen, a commitment to stretch the boundaries of thought, instrumentation, and imagination. In embracing the invisible, humans affirm their capacity to reason beyond perception, to seek patterns in the intangible, and to participate in the ongoing revelation of cosmic truth. Furthermore, the study of dark matter has implications for our understanding of time, history, and cosmic evolution. Dark matter plays a critical role in the formation of large-scale structures in the universe. Its gravitational pull shaped the clustering of galaxies, the filamentary network of the cosmic web, and the distribution of matter that eventually allowed stars, planets, and life to emerge. In this sense, the invisible has left indelible marks on the visible, a testament to the power of unseen forces in shaping outcomes over billions of years. For human thought, this is a compelling lesson that influence, causality, and impact are not always immediately apparent, that history, cosmic or human, is shaped by factors often hidden from view, and that understanding requires patience, abstraction, and imaginative inference. Dark matter also encourages a re-evaluation of what it means to see or know. Traditional epistemology, grounded in direct observation and sensory confirmation, is challenged by a universe in which the most significant structures are invisible. Knowledge becomes an act of inference, modeling, and synthesis. Understanding requires not only the collection of data, but the capacity to interpret subtle effects, to discern patterns from indirect evidence, and to construct coherent conceptual frameworks. In this light, human curiosity emerges as a uniquely adaptive trait, the ability to navigate uncertainty, to reason about absence as well as presence, and to engage with reality even when it eludes direct perception. In contemplating dark matter, we are also invited to reflect on the broader implications of invisibility in human life. Just as the universe is shaped by unseen forces, human existence is influenced by structures, systems, and dynamics that are not immediately apparent. Cultural norms, psychological tendencies, ethical imperatives, and historical contingencies. Recognizing the unseen can deepen empathy, enhance strategic thinking, and foster a more nuanced appreciation of causality and responsibility. The universe, in this sense, becomes both a laboratory and a mirror, a source of scientific insight and philosophical reflection. Curiosity, guided by the lessons of the cosmos, encourages us to seek understanding beyond appearances, to consider hidden influences, and to approach complexity with both rigor and humility. Finally, dark matter reminds us that the pursuit of knowledge is a profoundly human endeavor, combining observation, abstraction, imagination, and persistence. It demonstrates that the universe is at once knowable and elusive, that reality is layered with visible and invisible dimensions, and that human curiosity thrives, not despite limits, but because of them. To study dark matter is to engage in an intellectual adventure that stretches across disciplines, unites theory and observation, and illuminates the extraordinary capacity of the mind to grapple with the unseen. In this pursuit, science becomes more than a collection of facts. It becomes a mode of thought, a way of inhabiting reality that honors both mystery and understanding. Dark matter, invisible though it may be, leaves a visible impact, not only on galaxies and cosmic structures, but on human thought, philosophy, and imagination. It challenges us to expand the boundaries of perception, to develop sophisticated tools of inquiry, and to cultivate a mindset capable of reasoning about the unseen. It compels us to recognize that the universe is more than the sum of its observable parts, that reality extends beyond immediate experience, and that curiosity is the bridge between what is seen and what is inferred. In this sense, dark matter becomes a symbol, a reminder that the pursuit of understanding is an ongoing journey, defined not by certainty but by wonder, rigor, and the willingness to confront the invisible. In the final analysis, dark matter teaches us that reality is richer, stranger, and more intricate than our senses reveal. It compels humility, inspires imagination, and illuminates the profound capacities of human cognition. It invites us to think deeply about the nature of influence, causality, and existence itself, to recognize the power of the unseen in shaping the visible, and to embrace curiosity as both a tool and a philosophy. The universe, dominated by invisible forces, continues to challenge, inspire, and provoke us, revealing that, in the dance between light and darkness, seen and unseen, human thought finds its greatest opportunity to explore, understand, and marvel. For nebulae and the art of creation and transformation. In the boundless expanse of the cosmos, nebulae stand as luminous monuments to both creation and transformation. They are clouds of gas and dust, vast in scale, and yet intricate in structure, glowing with the combined energy of countless stars. To gaze upon a nebula is to witness the raw material of the universe in motion, a canvas on which the cycles of birth, evolution, and renewal are painted in incandescent hues. Nebulae are both laboratories and theaters, sites where matter coalesces into stars, planets, and ultimately, the building blocks of life itself. They invite us to contemplate not only the processes of astrophysical formation, but also the broader themes of transformation, impermanence, and the infinite potential inherent in the universe. These celestial clouds are the progenitors of cosmic structures. Within the seemingly chaotic folds of a nebula, gravity orchestrates a delicate ballet. Dense regions collapse under their own weight, forming protostars that will ignite in thermonuclear fusion and illuminate the surrounding cloud. Over millions of years, these regions may birth entire star systems, each a miniature cosmos, each a testament to the generative power of unseen forces. The act of creation within nebulae is both violent and beautiful. Shockwaves ripple through the clouds, supernova remnants compress matter, and radiation sculpts intricate filaments of gas and dust. In every swirl and fold, the universe demonstrates that creation is not a static event, but a dynamic process, a continuous transformation that links past, present, and future in an intricate web of cause and consequence. The most famous nebulae, from the Orion Nebula to the Eagle Nebula, with its iconic pillars of creation, exemplify this interplay of structure and chaos. Their forms are shaped by competing forces, gravity drawing matter inward, stellar winds and radiation pushing outward. These interactions create striking visual patterns, yet beneath the beauty lies an essential lesson. Creation is never a solitary, passive act. It emerges from the tension between opposing dynamics, from the negotiation of forces that may seem destructive, yet are, in fact, generative. Human experience mirrors this cosmic principle. Our growth, creativity, and understanding often emerge not from tranquility but from engagement with challenge, tension, and transformation. Nebulae, in this sense, are both astrophysical phenomena and metaphors for the processes of human development. The study of nebulae also illuminates the temporal dimensions of the universe. The formation of stars and planetary systems unfolds over millions of years, timescales that dwarf human experience. This vast temporal perspective encourages a profound sense of patience and humility. In observing nebulae, we confront the slow, deliberate rhythms of cosmic evolution, realizing that what appears static in the night sky is in fact a continuous unfolding of energy and matter. For the human mind, accustomed to the immediacy of daily experience, this perspective challenges conventional notions of time and progress. It invites us to consider the long arcs of transformation, the hidden processes that shape outcomes over immense durations, and the extraordinary patience inherent in natural creativity. Nebulae also challenge our understanding of materiality and permanence. They are composed of the simplest elements, hydrogen and helium, with traces of heavier atoms. Yet these humble components give rise to astonishing complexity. Through the processes of fusion, supernovae, and accretion, these atoms are transformed into new elements, new structures, and new potentialities. In this way, nebulae embody the principle that from simplicity emerges complexity, from randomness emerges order, and from impermanence emerges the potential for renewal. This principle resonates deeply with human thought and creativity, reminding us that beginnings are often unassuming, that transformation requires both time and the interplay of forces, and that even the most delicate and transient elements can give rise to enduring structures and profound beauty. The light emitted by nebula is itself a testament to the transformative power of energy. Photons excite atoms, causing them to radiate in vibrant colors: reds from hydrogen, blues from oxygen, greens from sulfur, each emission a signature of elemental identity and energy state. These glowing patterns are not merely aesthetic, they are physical records of energetic interactions, of matter responding to force, of creation made visible. Observing these emissions allows astronomers to deduce chemical compositions, densities, temperatures, and dynamics within the clouds, translating beauty into knowledge. For human observers, this dual aspect, visual splendor and scientific insight, reinforces a profound truth: the universe is at once a work of art and a subject of study, a form in which aesthetic appreciation and intellectual inquiry are inseparable, each enhancing the other. Nebulae also demonstrate the cyclical nature of existence on cosmic scales. Many nebulae are remnants of dead or dying stars, clouds formed from the ejected material of supernova explosions. These stellar deaths are not mere endings, but beginnings. The expelled matter enriches the interstellar medium with heavier elements, seeding future generations of stars, planets, and potentially life-bearing worlds. In this way, death and destruction are inseparable from creation and renewal. The universe recycles its matter in an eternal cycle, a process that mirrors biological, social, and psychological patterns in human experience. By observing nebulae, we gain insight into the interconnectedness of existence, the inevitability of change, and the potential for transformation inherent in endings as well as beginnings. The physics within nebula is a complex interplay of forces, revealing the subtlety and elegance of cosmic processes. Magnetism threads through the clouds, guiding the collapse of matter along invisible lines. Turbulence and shock fronts fragment and shape the clouds, creating localized density variations that determine the sites of star formation. Radiation pressure from nearby stars sculpts cavities and filaments, while gravity continually pulls matter inward, negotiating the delicate balance between collapse and dispersal. These processes are governed by the same fundamental laws of physics that operate on Earth, yet they manifest on scales and intensities that exceed ordinary experience. Nebula thus exemplify the principle that universal laws are both consistent and endlessly adaptable, producing patterns of astonishing complexity and beauty across vastly different contexts. Human engagement with nebula has long been a source of inspiration for art, philosophy, and culture. Their luminous clouds have been depicted in paintings, literature, and visual media as symbols of mystery, creativity, and transcendence. Yet the fascination they inspire is grounded not only in their aesthetic qualities, but in the profound insights they offer about the nature of existence. They reveal the interplay of order and chaos, the process by which matter organizes itself into increasingly complex structures, and the transformative potential inherent in the universe. For humans, these insights encourage reflection on personal and collective growth, the processes by which knowledge and creativity emerge, and the ways in which engagement with challenge and change can generate beauty and meaning. Nebulae also serve as laboratories for understanding chemical evolution. Within their clouds, simple molecules combine to form more complex organic compounds, including precursors to the molecules essential for life. Observations have detected amino acids, alcohols, and other organic molecules, suggesting that the raw ingredients for biology are widespread in the universe. This realization extends the significance of nebulae beyond stellar and planetary formation to the potential emergence of life itself. In contemplating these processes, we confront questions of origin and possibility, recognizing that creation is not confined to isolated events, but is a continuous, emergent process that links the evolution of matter, energy, and potentially consciousness across vast spans of space and time. The study of nebulae also challenges human cognition, inviting us to reconcile scales of space and time far beyond everyday experience. To appreciate the dynamics within a nebula, one must imagine distances of light years, time spans of millions of years, and processes occurring at velocities and energies that defy intuition. This requires an expansion of thought, a willingness to operate within abstract frameworks, and the cultivation of a perspective that transcends immediate perception. In doing so, we exercise a uniquely human capacity, the ability to conceptualize the invisible, to reason about processes that cannot be directly witnessed, and to derive meaning and understanding from patterns that unfold over incomprehensible scales. Curiosity, guided by observation and imagination, becomes both a cognitive and philosophical endeavor, bridging the gap between the tangible and the abstract. Nebulae also remind us that creation is inherently collaborative. Within their clouds, countless particles of gas and dust interact, collide, and coalesce under the influence of gravity, magnetism, and radiation. No single atom dictates the formation of a star. The process emerges from the collective dynamics of many components. This principle has profound resonance for human societies and intellectual pursuits. Just as stars arise from the interactions of countless particles, human knowledge, creativity, and achievement emerge from collaboration, dialogue, and the integration of diverse contributions. Nebulae thus serve as cosmic metaphors for the generative potential inherent in cooperation, interconnection, and the interplay of forces that individually may seem insignificant but collectively produce extraordinary outcomes. Moreover, nebulae illuminate the transformative power of energy. The radiation emitted by young stars ionizes surrounding gas, triggering waves of star formation, sculpting the cloud's structure, and driving the chemical reactions that create new molecules. Supernova explosions inject enormous amounts of energy into the interstellar medium, compressing clouds, initiating collapse, and enriching the environment with heavier elements. In this way, energy acts as both a destructive and creative force, demonstrating that transformation often arises from tension, interaction, and the movement of matter through dynamic states. Human experience echoes this principle. Growth, learning, and creativity frequently emerge from the interplay of challenge and opportunity, disruption and renewal. The beauty of nebula, while apparent in telescopic images, is inseparable from their underlying processes. The luminous filaments, glowing knots, and vast diffuse regions are manifestations of fundamental physics shaped by gravity, thermodynamics, and electromagnetic interactions. Understanding this underlying reality does not diminish their splendor, rather, it deepens it. To recognize the processes at work within a nebula is to appreciate the elegance, precision, and inevitability of cosmic transformation. Human curiosity, when aligned with careful observation and theoretical insight, allows us to see both the aesthetic and structural dimensions of these clouds, enriching our experience of wonder and our comprehension of the universe's creative capacities. Finally, nebula remind us that creation is continuous. emergent and infinite in potential. Each star that ignites within a nebula may live for millions or billions of years, eventually returning its matter to the interstellar medium, contributing to the formation of new stars and planets, and perpetuating the cosmic cycle. This endless cycle of creation, transformation, and renewal is both humbling and inspiring. It encourages a perspective in which beginnings and endings are not fixed, but fluid, where change is constant and where the potential for new structures, forms, and life is ever present. In contemplating nebulae, we recognize that the universe is not static but dynamically creative, a realm in which matter, energy, and forces interact in ways that generate novelty, complexity, and beauty across unimaginable scales. Nebula, therefore, are more than astronomical phenomena. They are profound teachers, offering lessons about creation, transformation, and the emergence of complexity. They illuminate the principles by which matter organizes itself, the dynamics of energy and force, and the temporal scales over which cosmic evolution occurs. They inspire reflection on the nature of creativity, both in the universe and within human endeavor, highlighting the interplay of simplicity and complexity, chaos and order, destruction and renewal. In this way, nebula bridge the physical and the philosophical, revealing insights about the cosmos while inviting contemplation of our own processes of growth, learning, and transformation. In the final analysis, to study nebulae is to engage with the universe at its most generative and transformative levels. They exemplify the intricate dance of forces that shape stars, planets, and life itself, offering a window into the processes by which the cosmos continuously reinvents itself. They challenge us to expand our imagination, to appreciate both the beauty and the mechanics of creation, and to recognize that transformation is a constant, universal principle. Nebulae, luminous, dynamic, and endlessly fascinating, remind us that creation is not a singular event, but an ongoing process, that transformation is the essence of existence, and that human curiosity, aligned with observation, imagination, and reflection, allows us to participate in the eternal art of understanding the cosmos. 5. Time dilation and the human experience of mortality. Time is the dimension in which our lives unfold, the silent current that carries moments from birth to death, from experience to memory. We perceive it as steady, relentless, and uniform, flowing in one direction, shaping the narrative of our existence. Yet, when we look to the cosmos, when we explore the depths of physics and relativity, this familiar conception begins to unravel. Time, as revealed by Einstein's theories of relativity, is not absolute. It bends, stretches, and contracts, influenced by gravity and velocity, revealing a universe in which the flow of moments is intimately tied to the structure of space itself. This phenomenon, known as time dilation, challenges our intuitive understanding and invites profound reflection on mortality, perception, and the human experience of life. In the realm of high velocities, approaching the speed of light, time for a traveler slows relative to a stationary observer. This is not speculation. It is an empirically verified consequence of special relativity. Particles accelerated to near light speeds in laboratories age more slowly than their counterparts at rest, and atomic clocks flown aboard aircraft or satellites tick at slightly different rates than identical clocks on the Earth's surface. The implication is staggering. The passage of time is not a universal constant, but a malleable dimension, contingent upon motion and gravity. The cosmos itself does not measure time in the same way for all observers. This realization destabilizes the intuitive foundation of human experience, reminding us that our perception of temporal flow is localized, subjective, and intimately connected to the environment we inhabit. Time dilation also occurs in gravitational fields. General relativity predicts that clocks situated closer to massive bodies tick more slowly than those farther away. On Earth, this effect is minuscule but measurable. Near a neutron star or black hole, it becomes extreme. Imagine approaching the event horizon of a black hole. An hour for the traveler might correspond to years for an observer far away. In this extreme scenario, the human experience of time diverges dramatically, from the cosmic standard. The intimate connection between gravity and temporality reveals that life, aging, and mortality are not fixed absolutes but phenomena defined by context. In contemplating this, we begin to perceive mortality not only as a personal inevitability, but as a relative, flexible construct within the fabric of space-time itself. This scientific understanding of time carries profound philosophical implications. If time can bend and stretch, if the progression of moments depends upon position and motion, then the familiar narrative of linear progression becomes less absolute. Past, present, and future are not universally fixed, but are partially observer-dependent. This challenges human conceptions of causality, legacy, and the meaning of action. What we consider fleeting or permanent may exist differently from the perspective of distant observers, accelerated travelers, or extreme gravitational environments. In this light, human mortality is both immediate and relative, a unique perspective within a cosmos in which temporal experience is fluid and contingent. The implications extend to the very notion of existence. If the universe allows for the differential flow of time, then our lives, though limited from our own perspective, are embedded within a vast, multi-temporal context. Our choices, achievements, and experiences exist not in isolation, but within a complex temporal landscape, one in which the same moment may be experienced differently depending on motion, gravity, or spatial position. This realization invites reflection on the nature of significance and impermanence. Mortality, while absolute in human perception, is contextual within the larger cosmos. Our awareness of this relativity can transform how we approach life, imbuing each moment with both urgency and humility. Human culture and psychology are deeply shaped by our perception of time. We organize our lives around calendars, clocks, and rituals, establishing frameworks to impose order on the inexorable flow of events. Yet, the universe teaches us that these frameworks are approximations, practical conventions anchored in local experience rather than universal truths. Recognizing the fluidity of time challenges us to reconsider priorities, values, and the meaning of life. It invites a mindset in which the present moment, though transient, gains extraordinary significance, in which awareness of mortality is both a limitation and an inspiration, and in which curiosity, exploration, and connection acquire heightened urgency, precisely because the passage of time is neither fixed nor uniform. Time dilation also encourages profound reflection on legacy and memory. Our cultural and personal artifacts, books, art, scientific knowledge, recorded histories, are attempts to extend human presence across time, to communicate with observers who will experience our creations in the future. Yet, in a universe governed by relative temporal flow, the persistence of these legacies is both astonishing and fragile. A civilization near a black hole might perceive our era as compressed into an instant, while our own perception stretches across decades. The human desire to leave a mark, to achieve continuity beyond the confines of individual lifespan, is therefore deeply intertwined with the nature of time itself. Mortality becomes not merely an endpoint, but a relational phenomenon, measured not only in years but in the resonance of influence across spatial and temporal scales. In considering time dilation, we also confront existential questions about identity and consciousness. If the flow of moments is relative, if subjective experience can diverge from external measurements, then consciousness itself is embedded within a flexible temporal framework. Aging, memory, anticipation, and perception are all bound to the local conditions of space-time. This realization emphasizes the preciousness of lived experience. Each moment, though transient, is profoundly unique. Human life, though finite from our perspective, is experienced in a flow of time that is deeply personal and contextually situated. The relativity of temporal experience encourages both reflection and presence, reminding us that the awareness of mortality is inseparable from the appreciation of immediacy. Time dilation also offers profound insight into the tension between eternity and impermanence. In everyday life, human mortality confronts us with finitude, the inevitability of birth, decay, and death. Yet in the context of relativistic physics, Moments of life are simultaneously fleeting and enduring, relative to distant observers or high-velocity environments. The cosmos demonstrates that the passage of time is not a monolithic force, but a relational property dependent on context, environment, and perspective. This duality resonates with human intuition and existential reflection. Our lives are brief from one vantage point, yet may ripple across the universe in ways we cannot fully perceive. Mortality is immediate, yet within the framework of the cosmos, it participates in a broader, multi-layered temporal narrative. The concept of time dilation also reframes our understanding of causality and consequence. Actions, decisions, and events are perceived in the context of relative time. From a cosmic perspective, the sequence of events is not absolute. What seems linear and necessary from one vantage may appear compressed, extended, or differently ordered from another. This challenges the human desire for fixed narrative and absolute determinism, inviting a recognition of contingency, perspective, and uncertainty. Mortality, therefore, is not merely a biological endpoint, but a relational phenomenon bound to the interplay of motion, gravity, and perception. In this view, life gains both urgency and depth. Each choice is contextual, each moment unique, and each awareness of limitation a catalyst for reflection, creativity, and engagement. Time dilation also has profound implications for interstellar exploration and the human imagination of the future. If humans travel at velocities approaching light speed, the subjective experience of aging could diverge dramatically from Earth-based time. A voyager may perceive decades of travel while centuries pass at home. This scenario challenges familiar notions of generational continuity, social connection, and historical awareness. Mortality in this context is experienced differently for different observers, and the passage of life becomes a dynamic interplay between physical circumstance and perception. Science fiction has long explored these themes, yet they are grounded in empirical physics, offering tangible insight into the relativity of experience and the profound flexibility of temporal reality. The psychological and philosophical impact of these insights is equally significant. Awareness that time is not absolute fosters humility. Our perception is limited, our understanding partial, and our narratives contingent, yet it also fosters wonder and aspiration. The universe is more intricate, more dynamic, and more expansive than everyday experience suggests. The finite nature of human life, juxtaposed with the malleability of time in extreme environments, encourages reflection on priorities, purpose, and the ways in which consciousness engages with the world. Mortality is no longer merely a biological limit. It becomes an invitation to engage deeply, to create, to explore, and to experience life with full awareness of its fleeting yet relational dimensions. Time dilation also reframes ethical and philosophical considerations. If life is experienced differently across frames of reference, if moments have relative significance, then human responsibility gains a new dimension. Our actions ripple not only in the immediate temporal context, but within a framework in which time itself is fluid. This recognition amplifies the importance of intentionality, mindfulness, and foresight. Mortality, understood in this cosmic context, is intertwined with relational awareness, empathy, and the understanding that existence is not singularly linear, but embedded in a complex, multi-perspective tapestry of time, consequence, and influence. The interplay of time dilation and mortality also invites reflection on the aesthetic and existential dimensions of human life. Art, literature, music, and philosophy are all attempts to capture the passage of time, to preserve experience, and to communicate across temporal divides. In recognizing that time itself is relative, these efforts acquire an added depth. They are not merely cultural artifacts, but interventions in the continuum of experience, shaping perception, thought, and emotion across diverse temporal and spatial contexts. Human creativity becomes a bridge across temporal scales, a means of engaging with mortality, and a way of participating in a cosmos in which time itself is flexible, dynamic, and profoundly generative. Moreover, the concept of time dilation encourages a re-evaluation of narrative, memory, and meaning. The stories we tell about our lives, the frameworks we construct to understand experience, and the milestones by which we measure aging are all anchored in local temporal perception. Yet the cosmos demonstrates that these anchors are provisional, relative, and context-dependent. This insight encourages openness, flexibility, and philosophical reflection. It reminds us that human experience, though bounded and finite, participates in broader temporal structures, and that the perception of mortality is both a personal and relational phenomenon, shaped by context, perspective, and the inherent flexibility of space-time itself. Finally, time dilation invites wonder at the profound interplay between physics and existence. It reveals a universe in which the flow of moments is not absolute, in which aging, duration, and sequence are relational, and in which mortality is experienced differently depending on context. It challenges human assumptions, stimulates intellectual and philosophical reflection, and deepens appreciation for the complexity of life and the cosmos. In this light, mortality is not merely a constraint, it is a lens, a teacher, and a catalyst for curiosity, creativity, and engagement. The relativity of time enriches our understanding of existence, urging us to live with both awareness and imagination, to contemplate the universe while fully inhabiting the fleeting, precious moments that define our ideal experience. In the final analysis, time dilation transforms our understanding of mortality from a rigid, uniform endpoint into a dynamic, relational phenomenon. It teaches that human life, though finite, is embedded within a cosmos of extraordinary complexity and scale. Our perception of time, our experience of aging, and our awareness of death are intimately connected to our position, motion, and context within space-time. This insight does not diminish the significance of human existence, it amplifies it. Every moment gains weight, every choice acquires resonance, and the awareness of mortality becomes an impetus for engagement, reflection, and exploration. Time, in its relativity, illuminates the profound capacity of the human mind to perceive, to imagine, and to find meaning within a universe in which the passage of moments is both real and astonishingly flexible. Time dilation, in its full scope, is not merely a scientific phenomenon, it is a profound meditation on existence. It invites us to consider the fragility and resilience of life, the relativity of experience, and the extraordinary potential for consciousness to engage with a cosmos far beyond immediate perception. Mortality, viewed through this lens, is both immediate and relative, intimate and cosmic, constrained and expansive. It reminds us that human curiosity, creativity, and reflection are inseparable from temporal awareness, and that understanding our position in the flow of moments enriches every facet of experience. To contemplate time dilation is to confront the limits of perception, the depth of possibility, and the beauty of existence, and in doing so to recognize that life, though finite, is profoundly meaningful, and that the universe, in its relativity, invites us to participate fully, consciously, and imaginatively in the unfolding of time itself. 6. Exoplanets and the search for other civilizations. Beyond the familiar orbits of our solar system lies an immense and largely uncharted cosmic landscape, a universe teeming with stars, each potentially accompanied by worlds unlike any we have known. These worlds, the exoplanets, challenge our imagination, our understanding of planetary formation, and most profoundly, our sense of place in the cosmos. From the first confirmed detection of an exoplanet orbiting a sun-like star in 1995, to the thousands discovered since, the study of these distant worlds has evolved from speculation into a rigorous and rapidly expanding field, revealing a universe far more diverse, intricate, and mysterious than the few planets of our solar system might suggest. Exoplanets are, in many ways, windows into possibility. They vary in size, composition, orbit, and atmosphere, ranging from gas giants larger than Jupiter to rocky planets smaller than Earth, from scorched, tidally locked worlds to frozen, distant orbs bathed in faint starlight. Some orbit perilously close to their host stars, experiencing searing temperatures and tidal forces that warp their shape, while others drift in wide, languid orbits, bathed in the gentle illumination of distant suns. Each exoplanet represents a unique laboratory, a set of physical conditions distinct from any found in our own system, offering clues to the fundamental processes of planetary formation, evolution, and habitability. The sheer variety of these worlds reminds us that the universe is not uniform, not constrained to our expectations, but astonishingly creative, generating environments that defy simple classification and challenge human imagination. The discovery of exoplanets has profound implications for our understanding of life itself. For centuries, humanity has pondered the question of whether we are alone in the cosmos, whether intelligence, consciousness, and civilization might emerge elsewhere under the right conditions. The study of exoplanets brings this question into sharper focus, providing empirical data that inform the likelihood of habitable worlds. Astronomers search for planets within the so-called habitable zone of their stars, where temperatures allow for the presence of liquid water, a prerequisite for life as we understand it. They analyze atmospheric spectra for signatures of molecules like oxygen, methane, and carbon dioxide, which, in certain ratios, may indicate biological activity. Each candidate detection stirs the imagination. Could there be a world where life has arisen independently, following evolutionary paths both familiar and utterly alien? The very act of searching for other civilizations reshapes our perspective on ourselves. For the first time in history, humanity possesses the tools to measure not only the existence of distant worlds, but also the potential signs of life and intelligence across vast cosmic distances. This knowledge positions us not as the solitary center of creation, but as participants in a universe of possibility, where our own civilization is one node in an unimaginably vast network of potential sentient beings. The implications are both exhilarating and humbling. We are at once ordinary as one species among countless worlds, and extraordinary as a species capable of asking these questions, detecting distant planets and contemplating the nature of life itself on a cosmic scale. The techniques used to detect and characterize exoplanets are marvels of human ingenuity. Transit photometry measures the minute dimming of a star as a planet passes in front of it, revealing the planet's size and orbital period. Radial velocity methods detect the gravitational tug of a planet on its host star, offering insight into mass and orbit. Direct imaging, though challenging, allows astronomers to capture the faint light reflected or emitted by the planet itself. Each method is a triumph of precision, enabling the detection of objects trillions of miles away, whose presence is inferred through subtle effects on their environment. These techniques reflect the remarkable capacity of human cognition, engineering, and perseverance to reach across vast distances and extract knowledge from signals that are barely perceptible, revealing worlds that exist only as faint whispers in the data we collect. Exoplanet discoveries also challenge our understanding of planetary system formation. The prevalence of hot Jupiters, gas giants orbiting extremely close to their stars, contradicted prior models based on our own solar system and forced theorists to rethink the dynamics of planetary migration and gravitational interaction. The diversity of planetary architectures, from compact multi-planet systems to widely spaced arrangements, reveals that planetary formation is a flexible, adaptive process influenced by initial conditions, stellar activity, and interactions with other bodies. This diversity underscores a fundamental truth: the universe does not produce planets in a single template, but in countless variations, each with its own potential for unique evolutionary trajectories, climates, and possibilities for life. The search for biosignatures on exoplanets is among the most exciting frontiers in science today. By analyzing the light that filters through or reflects off a planet's atmosphere, scientists can detect chemical imbalances that may indicate the presence of life. Oxygen, in combination with methane or other reactive gases, could signify ongoing biological processes. Clouds of water vapor, atmospheric composition, and seasonal variations provide additional clues, allowing researchers to construct probabilistic assessments of habitability. Every spectral line, every anomaly, is a data point in a vast cosmic puzzle, inviting interpretation and speculation. The possibility that we might detect life beyond Earth transforms the study of exoplanets from an abstract exercise into a profoundly existential inquiry, with implications for philosophy, religion, and the self-understanding of our species. The implications for civilization-scale detection commonly associated with the search for extraterrestrial intelligence or SETI are equally profound. Advanced civilizations, if they exist, may produce observable techno-signatures, artificial radio transmissions, industrial pollutants in atmospheres, or even large-scale engineering projects that alter the light emitted from their planets. Detecting such signals would be a paradigm-shifting event, demonstrating that intelligent life can arise elsewhere and survive long enough to leave detectable traces. Even in the absence of confirmed detections, the search itself reframes human perspective, emphasizing the possibility of community interaction and shared curiosity on a galactic scale. Each exoplanet observed is a reminder that the universe is not empty but alive with potential, a vast stage upon which life may have emerged in forms we cannot yet imagine. Exoplanets also illuminate questions of temporality and evolution. A planet observed today may harbor life that began billions of years ago, evolved independently, and develop technologies far beyond our comprehension, or it may be at the earliest stages of habitability, where life has yet to arise. The observation of distant worlds is thus a study in cosmic time, a glimpse across the vast epochs that separate stellar and planetary evolution from our human lifespan. This perspective encourages reflection on the fleeting and precious nature of life on Earth, while simultaneously inspiring awe at the persistence of cosmic processes over billions of years. Humanity, though brief in the cosmic timeline, participates in a tradition of observation, understanding, and exploration that connects us to the deep history of the universe. The search for exoplanets has also transformed our cultural imagination. Science fiction, once purely speculative, increasingly draws upon empirical discoveries to construct plausible visions of alien worlds, civilizations, and interstellar encounters. These narratives are not mere flights of fancy. They are exercises in extrapolation, grounded in observed physics, chemistry, and planetary science. They challenge us to consider alternative modes of life, social organization, and cognition, expanding our empathy and imagination. The interplay between discovery and imagination demonstrates that human curiosity is not limited to direct observation. It thrives in the interplay of evidence, theory, and creative speculation, forging a richer understanding of our place in the cosmos. Exoplanets, moreover, inspire a renewed appreciation for Earth itself. In observing countless distant worlds, we recognize the extraordinary set of conditions that make our planet habitable. The stability of its orbit, the presence of liquid water, the protective magnetic field, and the complex interplay of atmosphere, oceans, and biosphere. The search for other worlds underscores the rarity and fragility of these conditions, heightening awareness of environmental stewardship, planetary protection, and the responsibility that accompanies intelligence and consciousness. Each exoplanet serves as both a mirror and a contrast, reminding us of the unique balance that sustains life on our own world, while simultaneously hinting at the vast diversity that the universe can generate. The technological and methodological advancements that have enabled exoplanet research are a testament to human ingenuity. Space telescopes like Kepler, TESS, and the James Webb Space Telescope provide unprecedented sensitivity, allowing the detection of minute variations in starlight and the analysis of planetary atmospheres with extraordinary precision. Ground-based observatories employ adaptive optics and spectroscopic techniques to overcome the distorting effects of Earth's atmosphere. Each advancement reflects not only the refinement of tools but the evolution of human curiosity, demonstrating our capacity to extend perception across unimaginable distances, to translate faint signals into profound insight, and to continuously push the boundaries of what is knowable. The potential discovery of other civilizations carries profound philosophical implications. If life and intelligence are widespread, then humanity is part of a larger cosmic story, a chapter in an ongoing, multi-planetary narrative. If life is rare, if intelligence is exceptional, then the uniqueness of our perspective and responsibility becomes even more pronounced. In either scenario, the search itself, the meticulous observation of exoplanets, the analysis of spectral data, careful calibration of instruments, is a reflection of human aspiration, the desire to connect, to comprehend, and to situate ourselves within a universe that is both immense and intimate, cold and luminous, indifferent and awe-inspiring. Exoplanets also provoke reflection on contingency and probability. The emergence of habitable conditions depends upon countless variables: stellar type, planetary mass, orbital stability, magnetic shielding, atmospheric composition, and chemical abundance, among others. Each planet represents a unique configuration, a combination of circumstances that may permit life, preclude it, or create entirely novel conditions. By observing this diversity, humans gain insight into the fragility and resilience of life, the role of chance in evolution, and the vast range of possibilities that nature can generate. Curiosity becomes an exercise in probabilistic reasoning, a way of understanding not only what exists but what might exist, and the conditions under which intelligence could arise elsewhere. Furthermore, the study of exoplanets challenges the anthropocentric perspective. We are accustomed to thinking in terms of Earth-like conditions, solar-type stars, and familiar planetary dynamics. Yet the universe may host forms of life adapted to environments that are extreme, alien, and unrecognizable. Worlds with thick atmospheres of hydrogen or methane, planets bathed in radiation far beyond earthly levels, or tidally locked worlds with eternal day and night on opposite hemispheres. By expanding our conceptual frameworks, we are invited to imagine life not merely as an echo of ourselves, but as a broader principle, the emergence of complexity, adaptation, and consciousness under a wide variety of conditions. The search for exoplanets and other civilizations becomes a study in humility, imagination, epistemic flexibility. Finally, the pursuit of exoplanets and the potential discovery of life beyond Earth reminds us that curiosity is both a personal and collective endeavor. Each detection, each spectrum analyzed, each orbit calculated represents decades of collaborative work, thousands of minds focused on interpreting signals from distant stars. This endeavor transcends borders, disciplines, and generations. It embodies the uniquely human drive to explore, understand, and connect with the universe, a pursuit that bridges the gap between empirical measurement and existential reflection, between the minute details of observation and the vastness of cosmic possibility. In the final analysis, exoplanets and the search for other civilizations transform our understanding of the universe and ourselves. They challenge our assumptions, expand our imagination, and illuminate both the fragility and the resilience of life. They remind us that Earth is but one world among countless possibilities, and that intelligence, curiosity, and creativity are our tools for bridging the cosmic distance. Each exoplanet discovered, each spectrum analyzed, and each candidate for habitability examined is a step towards situating humanity within a broader cosmic context, a testament to the power of curiosity, observation, and imagination. In contemplating these distant worlds, we are invited to embrace both humility and wonder, to recognize the uniqueness of our existence, and to participate fully in the ongoing human endeavor to understand our place among the stars. 7. The multiverse: possibility, choice, and imagination. The universe we inhabit, with its stars, galaxies, and planets, appears immense, infinite even, yet it may be but one thread in a far larger cosmic tapestry. This is the provocative idea of the multiverse, a concept that stretches both physics and imagination, suggesting that our observable universe is one of countless others, each with its own laws, constants, histories, and possibilities. To contemplate the multiverse is to confront the limits of certainty, the boundaries of human perception, and the infinite potential of existence itself. It is an invitation to expand the mind, to explore the profound interplay between possibility, choice, and imagination, and to reconsider what it means to be human in a cosmos that may be far more vast and varied than our experience alone suggests. The origins of multiverse theory are rooted in the frontiers of physics, particularly in cosmology, quantum mechanics, and string theory. Inflationary cosmology posits that in the earliest moments of the Big Bang, space itself expanded exponentially, creating regions that became causally disconnected. Each region could evolve into a separate universe with its own properties, a unique cosmic experiment in matter, energy, and law. In quantum mechanics, the many worlds interpretation suggests that every quantum decision or event, every decay of a particle, every choice of an electron's path, may branch into a separate reality, an alternate universe where a different outcome is realized. Meanwhile, string theory hints at the existence of additional dimensions and configurations of space-time that could host entirely distinct universes. These ideas, while speculative, are grounded in rigorous mathematics and observation, pushing the boundaries of what science dares to contemplate. The multiverse challenges the human conception of possibility and contingency. In a cosmos where countless universes exist, every potential outcome may be realized somewhere. Worlds with different physical constants could exist, where stars never ignite, where matter behaves differently, or where consciousness evolves under entirely alien conditions. The very notion of probability takes on new depth. What we consider improbable in our universe may be inevitable across the totality of the multiverse. This realization stretches the imagination and reshapes philosophy. What is chance? What is necessity? And what is the measure of significance when every possibility is realized somewhere in the vast expanse of existence? The multiverse also reframes our understanding of choice and causality. If every decision, every quantum event generates branching realities, then the consequences of action become both immediate and infinite. Each moment of choice is not simply a linear progression, but a locus of divergence, a point at which reality unfolds along multiple trajectories. This is a radical expansion of perspective, inviting reflection on the nature of free will, responsibility, and the ethical dimensions of decision-making. In a multiverse context, every act is simultaneously unique and repeated, constrained and infinite, grounding human experience in a web of possibility far richer than everyday perception allows. We begin to see our lives not merely as isolated narratives, but as threads woven into a broader, multidimensional tapestry of potential. The scientific investigation of the multiverse, while challenging, has profound implications for cosmology and fundamental physics. Observations of the cosmic microwave background, the faint afterglow of the Big Bang, reveal anomalies and patterns that some interpret as possible evidence of collisions with other universes. The fine-tuning of physical constants in our own universe, which allows for the emergence of complexity, life, and consciousness, raises questions about whether these constants are uniquely determined or simply one realization among countless alternatives. The multiverse offers a potential explanation. We inhabit a universe in which conditions permit life because among the vast ensemble of universes such configurations are inevitable. This perspective reframes the anthropic principle, transforming what may seem improbable into a natural consequence of cosmic plurality. The implications of the multiverse extend beyond physics into philosophy, epistemology, and human imagination. It challenges the notion of a singular reality, prompting reflection on the limitations of perception, measurement, and certainty. If other universes exist beyond our observational horizon, then the cosmos is incomprehensibly vast, and our knowledge of it is necessarily provisional. This humbling perspective encourages intellectual humility, a recognition of the limits of certainty, and a profound appreciation for the scope of inquiry. At the same time, it stimulates imagination, inviting speculation about worlds radically different from our own, civilizations with alternative histories, and the emergence of life under unfamiliar laws of physics. The multiverse bridges rigorous science and creative thought, demonstrating that curiosity and imagination are mutually reinforcing modes of engagement with reality. The multiverse also resonates with deep existential and psychological themes. Consider the human preoccupation with possibility, regret, and the paths not taken. In daily life, we imagine alternate choices, different outcomes, and hypothetical scenarios. The multiverse literalizes this intuition on a cosmic scale. Every possible variation of events may exist somewhere, realized in a parallel reality. This concept can be both comforting and disorienting. Comforting, because it suggests that every potential life, every alternative path, has its expression somewhere in the vastness of reality. Disorienting, because it challenges the singularity of our experience, emphasizing that our perception of here and now is both limited and provisional. In this way, the multiverse bridges scientific and humanistic understanding, connecting cosmic theory with the lived experience of imagination, choice, and reflection. The mathematical structures underlying multiverse theories reveal profound symmetries, constraints, and possibilities. Inflationary cosmology, for example, provides a framework in which universes spontaneously nucleate from quantum fluctuations, each with its own spatial curvature, energy density, and initial condition. Quantum mechanics describes branching states, where the superposition of possibilities resolves into distinct outcomes, creating a lattice of alternative realities. String theory proposes a landscape of solutions, each corresponding to a universe with specific physical constants and dimensional arrangements. These mathematical insights are not mere abstraction, they shape our understanding of existence, providing rigorous, albeit highly speculative, models of how multiplicity can arise from fundamental laws. The elegance and coherence of these frameworks reflect the deep interplay between logic, mathematics, and physical reality. The multiverse concept also invites reflection on creativity and imagination. To think in terms of multiple universes is to expand cognitive horizons, to consider worlds unconstrained by familiar laws, and to entertain scenarios that challenge intuition. It encourages speculative thought, not as fantasy but as disciplined imagination informed by physical principles. Science, philosophy, and art converge in this domain. Cosmologists model the formation of parallel universes, philosophers ponder the ethical and existential implications, and artists envision landscapes and beings beyond earthly experience. The multiverse becomes a shared space of intellectual and creative exploration, illustrating the human capacity to navigate uncertainty, abstract complexity, and radical possibility. In contemplating the multiverse, we also confront questions of identity and significance. If countless versions of ourselves exist, each following different trajectories, then what does individuality mean? What does choice mean? What is the measure of significance in a reality where every variation is realized somewhere? These questions are deeply unsettling, yet profoundly enriching. They invite reflection on the nature of consciousness, the relationship between self and environment, and the ethical responsibility inherent in decision-making. At the same time, they highlight the beauty and singularity of human experience. Though infinite variations may exist, the lived moment, the conscious perspective, and the capacity for reflection are as alone. Awareness of the multiverse magnifies the preciousness of subjective experience while situating it within a broader context of possibility. The multiverse also illuminates the limits and power of human perception. Our senses and instruments are confined to our observable universe, a fraction of a potentially infinite totality. Yet, through mathematics, simulation, and theoretical reasoning, we extend cognition beyond immediate perception, constructing models of realms we may never directly observe. This capability underscores a uniquely human trait, the ability to engage meaningfully with phenomena that cannot be sensed, to reason about the unseen, and to explore existence in abstraction and imagination. The multiverse exemplifies this power, challenging us to reconcile the known with the possible, the observable with the speculative, and the immediate with the infinite. The search for empirical evidence of other universes, while daunting, is an active frontier in science. Researchers examine cosmic background radiation for anomalies, study the distribution of galaxies for subtle gravitational effects, and consider high-energy phenomena that could hint at collisions or interactions with neighboring universes. Though direct observation may remain beyond our reach, these investigations exemplify the human capacity to probe the limits of knowledge, to extend inquiry beyond the familiar, and to confront questions that transcend traditional boundaries. The pursuit of multiverse evidence reflects the audacity of curiosity, the rigor of scientific method, and the willingness to engage with uncertainty on the grandest scales. The multiverse also reframes existential reflection. Humanity has long sought meaning in a singular cosmos, often placing itself at the center of narrative and significance. Multiverse theory challenges this anthropocentrism, suggesting that our universe is one possibility among countless others. Yet rather than diminishing significance, this perspective can amplify the wonder of existence. We are inhabitants of a universe that allows complexity, consciousness, and reflection, embedded in a grander reality of possibility. This broader context encourages both humility and inspiration, reminding us that while we may not control the cosmos, we can engage with it through understanding, imagination, and ethical reflection. Furthermore, the multiverse fosters philosophical and scientific creativity. The need to conceptualize realities that differ from our own stimulates new ways of reasoning, new forms of mathematics, and innovative approaches to cosmology. It encourages interdisciplinary thinking, linking physics with philosophy, computation with metaphysics, and observation with abstraction. The very act of contemplating multiple universes exemplifies the human capacity to navigate ambiguity, to reason beyond empirical limits, and to construct models of reality that accommodate both certainty and speculation. This interplay between imagination and rigor, between creativity and analysis, is emblematic of the uniquely human approach to knowledge and understanding. The multiverse also transforms our understanding of time and possibility. Each branching universe represents a different sequence of events, a distinct trajectory of causality. Past, present, and future are not singular but manifold, creating a landscape in which multiple outcomes coexist in parallel. This perspective resonates with the study of quantum mechanics, time dilation, and the relativity of perception, illustrating that human experience is but one thread in a vast, interconnected web of potentialities. The multiverse invites reflection on contingency, agency, and the delicate interplay between structure and chance, highlighting both the fragility and resilience of complex systems, including life, consciousness, and civilization itself. Finally, the multiverse inspires humility, awe, and wonder. It compels us to acknowledge the limits of perception, the provisional nature of knowledge, and the extraordinary power of human imagination. It challenges assumptions, stretches intellectual boundaries, and opens vistas of possibility that are at once scientifically grounded and profoundly speculative. It reminds us that reality is richer, more complex, and more varied than our immediate experience suggests, and that human curiosity, creativity, and reflection are our means of engaging meaningfully with this vast, multifaceted cosmos. In the final analysis, the multiverse illuminates the profound interplay between possibility, choice, and imagination. It invites us to explore not only the physical structure of reality, but the conceptual, ethical, and philosophical dimensions of existence. It challenges the singularity of experience, encourages the expansion of thought, and situates human life within a context of extraordinary breadth and richness. Each moment, each decision, each observation is a portal into an infinitely branching landscape of potential. To contemplate the multiverse is to engage with the limits of knowledge and the boundless scope of possibility, to recognize the power of imagination, and to affirm the capacity of human consciousness to navigate, reflect upon, and marvel at the infinite complexity of existence itself. 8. Cosmic catastrophes and resilience in human psyche. The universe in all its grandeur and splendor is not a tranquil expanse, but a realm of immense power, unpredictability, and relentless change. Stars explode, asteroids traverse vast interstellar distances, black holes devour matter, and gamma-ray bursts emit energies so immense they can alter entire regions of space. Cosmic catastrophes, events of staggering magnitude and scope, remind us that existence is bound by forces far beyond human control. Yet, in contemplating these cosmic upheavals, we also encounter an extraordinary reflection of human resilience, the capacity of the psyche to confront uncertainty, to process existential threat, and to transform all-wheat understanding, fear into curiosity, and vulnerability into creativity. The universe teaches us not only about the forces that shape reality, but about the mental frameworks that enable humans to thrive in the face of uncertainty. Cosmic catastrophes occur across scales that challenge comprehension. On the planetary level, Earth itself is a witness to near misses and historical calamities. Asteroid impacts, volcanic supereruptions, and geomagnetic reversals have repeatedly reshaped the biosphere. The Chicxulub impact, which contributed to the extinction of the dinosaurs 66 million years ago, illustrates the power of a single celestial object to transform life on a planetary scale. Yet within these cataclysms lies a paradox. The same forces that threaten existence also drive renewal, adaptation, and evolution. Mass extinctions, while devastating, open ecological niches catalyzing the emergence of new species and ultimately the rise of intelligent life. This interplay between destruction and creation mirrors psychological processes in humans. Crises provoke reflection, adaptation, and growth, fostering resilience and innovation. On a stellar scale, supernovae provide another striking example of cosmic transformation. These violent explosions, the deaths of massive stars, release more energy in a single event than our Sun will emit over its entire lifetime. They forge heavy elements, carbon, oxygen, iron, and beyond, that become the building blocks of planets, life, and consciousness. In the detonation, we witness both annihilation and creation intertwined. Matter is scattered, energy radiates across light years, and the seeds of new worlds are sown. For humans, these events exemplify the duality of catastrophe. Destruction is inseparable from the emergence of new structures, and vulnerability is a prelude to renewal. Observing supernovae evokes both fear and wonder, teaching us that resilience is not the absence of threat, but the ability to navigate it with understanding and imagination. The phenomenon of gamma-ray bursts further amplifies this cosmic perspective. These bursts, originating from collapsing massive stars or the merging of neutron stars, release energies so intense that they could sterilize entire planetary systems across thousands of light years. The very existence of life on Earth, precariously situated in a relatively benign region of the galaxy, underscores the rarity and fragility of habitable environments. Yet, in confronting the improbability of survival, humans cultivate a profound awareness of contingency and gratitude. The psyche, faced with existential threat, develops adaptive strategies. Awe becomes a mechanism for cognitive integration, fear transforms into curiosity, and awareness of mortality motivates creativity, cooperation, and exploration. Cosmic catastrophes, in this sense, act as mirrors for psychological resilience, revealing the interplay between external forces and internal fortitude. The study of near-Earth objects, asteroids and comets whose trajectories bring them into proximity with our planet, illustrates both vulnerability and proactive adaptation. Humanity has the capacity to detect, track, and model these potential threats with remarkable precision. Space agencies employ telescopes, orbital simulations, and risk assessment frameworks to identify objects that could collide with Earth, allowing for preventive measures such as deflection strategies or impact mitigation. This proactive stance exemplifies a uniquely human response to cosmic danger. Rather than passive acceptance, we engage with risk through knowledge, planning, and technological innovation. Our ability to anticipate catastrophe transforms fear into agency, demonstrating that resilience is not merely psychological, but also practical, informed by science and foresight. Cosmic catastrophes also highlight the role of imagination in resilience. Humans have long constructed narratives, myths, and speculative scenarios to process existential risk. Ancient cultures interpreted comets, eclipses, and meteor showers as omens, integrating uncertainty into cosmology and moral frameworks. Today, science fiction explores planetary impacts, supernovae, and interstellar disasters, providing a cognitive rehearsal for catastrophe. Through imagination, humans simulate extreme conditions, consider ethical dilemmas, and develop strategies for survival and adaptation. This interplay between reality and narrative allows the psyche to accommodate uncertainty, transforming abstract threat into conceptual mastery and emotional regulation. On the galactic scale, phenomena such as supermassive black holes demonstrate both awe-inspiring power and existential implication. These dense singularities, residing at the centers of galaxies, distort space and time, emitting radiation that can influence entire stellar neighborhoods. While distant from human reach, their presence underscores the universe's capacity for transformative violence, challenging anthropocentric assumptions of control and centrality. The human response to such knowledge is twofold. It provokes existential reflection, confronting the fragility of life, and it catalyzes curiosity, driving exploration, observation, and the expansion of understanding. Psychological resilience is thus intertwined with the capacity for wonder, the ability to process scale and threat without paralysis, and the integration of knowledge into a coherent worldview. The notion of resilience extends beyond individual psychology into collective human experience. Civilizations have endured natural catastrophes, from earthquakes and volcanic eruptions to climate shifts and pandemics, adapting their technologies, social structures, and cultural practices in response. Cosmic catastrophes, though often abstract and distant, inspire reflection on these patterns of adaptation. The recognition of vulnerability encourages collaboration, the development of monitoring systems, and the cultivation of contingency planning. Human societies mirror cosmic dynamics. Just as planetary ecosystems adapt to episodic upheaval, civilizations evolve in response to risk, demonstrating that resilience is both an individual and collective attribute. Resilience is further illuminated by the human capacity to seek meaning in the face of disaster. Encountering a comet, a supernova, or the threat of an asteroid impact, we are confronted with the impermanence and contingency of existence. The psyche responds by constructing narratives that integrate threat into understanding. Scientific inquiry transforms fear into knowledge. Philosophical reflection situates mortality within broader frameworks, and creative expression channels awe into art, literature, and innovation. This process exemplifies a profound cognitive flexibility, the ability to convert existential threat into intellectual, emotional, and cultural resources, transforming vulnerability into adaptive strength. The psychological response to cosmic catastrophe is also shaped by temporal perspective. Events on cosmic scales unfold over millions or billions of years, far exceeding human lifespans. Understanding these scales encourages patience, humility, and long-term thinking. Humanity's efforts to comprehend supernovae, gamma-ray bursts, and orbital mechanics reflect a temporal expansion of the mind, situating immediate experience within vast timelines. Resilience in this context is not merely reactive, but proactive. It encompasses the cultivation of foresight, the construction of knowledge networks, and the development of technologies capable of mitigating or navigating future threats. Awareness of cosmic temporality fosters both perspective and strategic insight, reinforcing the psychological and practical dimensions of adaptation. Cultural responses to cosmic catastrophes highlight the interplay between fear and fascination. Humans are drawn to extremes: the destructive power of a supernova, the collision of a comet, the gravitational pull of a black hole captivates imagination while simultaneously evoking existential concern. Art, literature, and film explore these themes, allowing society to simulate catastrophe safely, engage with threat, and rehearse adaptive strategies. Such engagement demonstrates that resilience is not merely a private trait, but a cultural practice, cultivated through shared narratives, collaborative problem-solving, and the integration of knowledge into collective imagination. The study of cosmic catastrophe also fosters epistemic humility. By confronting phenomena that dwarf human comprehension, we recognize the limits of perception, prediction, and control. The unpredictability of asteroid impacts, the complexity of stellar dynamics, and the incompleteness of cosmological models illustrate that certainty is provisional, and that adaptation requires ongoing observation, learning, and flexibility. This recognition reinforces psychological resilience by encouraging openness, critical thinking, and the capacity to navigate uncertainty without succumbing to despair. Awareness of our limitations paradoxically strengthens our ability to act, innovate, and thrive within them. Human ingenuity in response to potential cosmic catastrophes exemplifies a synthesis of knowledge, foresight, and creativity. Projects such as planetary defense initiatives, asteroid deflection studies, and early warning systems combine physics, engineering, and computational modeling to anticipate and mitigate risk. These efforts demonstrate that resilience is an active process, requiring engagement with uncertainty, investment in technology, and the cultivation of expertise. By transforming existential threat into actionable strategy, humanity asserts agency in a universe governed by forces indifferent to life, illustrating the synergy of cognition, foresight, and adaptive behavior. Cosmic catastrophes also provoke reflection on the fragility and preciousness of life. Awareness of asteroid impacts, supernovae, or gamma-ray bursts underscores the contingency of our existence and the rarity of stable, habitable environments. This awareness fosters not only caution, but also wonder, appreciation, and ethical reflection. Resilience is inseparable from meaning-making. The capacity to recognize vulnerability, to celebrate the extraordinary circumstances that sustain life, and to cultivate a sense of responsibility toward both current and future generations. Cosmic perspective thus amplifies both humility and agency, reminding us that the human psyche is capable of integrating threat and beauty, peril and purpose. The interplay between catastrophe and resilience is evident in the broader patterns of cosmic evolution. Galaxies collide, stars are born and die, and planetary systems undergo continual transformation. In each of these processes, destruction and creation are inseparable. The death of one star seeds the formation of others. The extinction of one species creates opportunity for new life. The human psyche mirrors these cosmic rhythms. Experiencing personal or societal disruption can catalyze creativity, insight, and growth, transforming trauma into adaptation. Understanding the universe in these terms fosters a mindset in which resilience is not reactionary but generative, emerging from engagement with challenge rather than avoidance. Psychological studies of risk perception further illuminate how humans respond to cosmic threats. Events that are distant, abstract, or probabilistic often evoke less fear than immediate, tangible risks. Yet, through education, visualization, and engagement with scientific knowledge, humans can cultivate awareness and preparedness. Cosmic catastrophes, though remote, provide a unique opportunity to practice long-range thinking, probabilistic reasoning, and emotional regulation. In this sense, resilience is both cognitive and emotional. It entails integrating knowledge of vast, threatening phenomena with grounded strategies for understanding and coping. The mind, in this dynamic, becomes a tool for navigating uncertainty, transforming potential paralysis into informed reflection and deliberate action. The existential dimension of cosmic catastrophes cannot be overstated. Awareness of asteroid impacts, stellar explosions, or planetary instability confronts humans with mortality, impermanence, and contingency on the largest scales. Yet, rather than paralyzing thought, this awareness can catalyze profound creativity, curiosity, and philosophical reflection. By situating individual and collective experience within the vastness of cosmic processes, humans develop perspective, resilience, and a nuanced understanding of significance. Awareness of potential catastrophe sharpens insight, amplifies empathy, and fosters a sense of stewardship over both our planet and our shared intellectual and cultural heritage. Finally, cosmic catastrophes inspire a profound appreciation for the fragility and beauty of life. Observing the universe's capacity for destruction heightens awareness of the rarity and resilience of habitable conditions. The capacity for consciousness, culture, and creativity is extraordinary precisely because it persists against a backdrop of potential annihilation. The human psyche, confronted with the immensity of threat, adapts through wonder, curiosity, imagination, and action. Cosmic catastrophes, then, are not merely events of physical consequence. They are mirrors for the mind, revealing the principles of resilience, the interplay of vulnerability and strength, and the transformative power of awe, reflection, and foresight. In the final analysis, the study of cosmic catastrophes illuminates the intimate connection between external forces and internal resilience. The universe is vast, unpredictable, and often violent, yet human consciousness is capable of integrating threat, deriving meaning, and fostering adaptive strategies. From the devastation of asteroid impacts to the luminous brilliance of supernovae, from the inscrutable pull of black holes to the invisible reach of gamma-ray bursts, we are reminded of both our fragility and our capacity for strength. The psyche, when confronted with the immensity of cosmic events, demonstrates extraordinary flexibility, creativity, and endurance. It translates fear into curiosity, vulnerability into foresight, and mortality into reflection. In this interplay, humans discover not only the power and majesty of the universe, but also the boundless capacity of the mind to adapt, endure, and thrive amidst uncertainty. 9. Light, gravity, and the nature of perception. Light is the messenger of the universe. Every photon that reaches our eyes, our instruments, and our telescopes carries with it information across space and time. It is through light that we perceive the cosmos. From the nearest planets to the most distant galaxies, from the faint glow of ancient stars to the spectacular eruption of supernovae. Yet light is not merely a passive conveyor of information. It is an active participant in the construction of reality, its behavior intertwined with the curvature of space, the pull of gravity, and the limits of human perception. Understanding light and gravity, therefore, is not merely a study of physics. It is an exploration of how we encounter, interpret, and even imagine the universe itself. Gravity, invisible yet omnipresent, shapes the cosmic landscape. It orchestrates the motion of planets, the collapse of stars, and the weaving of galaxies into elegant spirals. Yet gravity is more than a force. It is the curvature of space-time itself, as Einstein revealed in his theory of general relativity. Light travels along these curves, bending around massive objects, creating phenomena such as gravitational lensing, where the light from distant galaxies is warped and magnified by the gravity of intervening mass. Through such distortions, we gain glimpses of matter otherwise invisible, including dark matter that exerts influence without emitting or absorbing light. In this interplay, perception becomes a collaboration between light, gravity, and consciousness. What we see is mediated by the fabric of space-time itself, reminding us that observation is never a simple reflection of reality, but a negotiated encounter with its underlying structure. The speed of light sets the ultimate stage for perception. No information can travel faster. No observation can escape this universal limit. Light encodes not only spatial information, but temporal information. When we observe distant stars, we are seeing them as they were millions, even billions of years ago. The Andromeda galaxy, 2.5 million light-years away, presents itself as it existed long before human civilization emerged. Light, in this sense, is a temporal bridge, allowing us to perceive history as though it were present, transforming our understanding of immediacy and distance. Our perception is therefore simultaneously local and cosmic, anchored in the here and now, yet constantly in dialogue with the distant past. The universe communicates with us not instantaneously, but across the immense intervals of space and time, reminding us that understanding is always contingent, provisional, and filtered through the medium of light. Gravity and light together reveal the extraordinary relativity of perception. Near a black hole, for example, space-time curves so sharply that light itself is trapped, swirling in an inexorable spiral toward the singularity. Time slows for an observer near this immense mass, relative to a distant observer, illustrating that perception and experience are fundamentally context-dependent. A photon emitted from the vicinity of the event horizon carries information about both the geometry of space and the flow of time, revealing that what we see is inseparable from the environment in which observation occurs. Perception, in this light, is not a static recording, but a dynamic process shaped by the curvature of space, the warping of time, and the interaction of energy and mass. Understanding reality thus requires an appreciation of how observation itself is mediated by physical law. The nature of light challenges intuition. It behaves simultaneously as particle and wave, a duality that defies classical understanding yet is confirmed by countless experiments. Photons can interfere with themselves, creating patterns of constructive and destructive interaction, yet also arrive as discrete quanta interacting with matter in localized bursts. This duality reflects the profound complexity of perception. The universe is not reducible to simple, deterministic mechanisms, and what we observe depends upon how we observe it. Instruments extend our perception, revealing aspects of reality inaccessible to the unaided eye, yet they also impose interpretive frameworks. The human mind, in concert with technology, becomes an instrument of decoding, translating subtle signals into understanding, transforming light into knowledge and confronting the paradoxes inherent in the fabric of existence. Color, intensity, and polarization of light reveal the physical and chemical composition of distant objects. Spectroscopy allows us to dissect starlight, revealing the elements forged in stellar cores, the motion of galaxies receding into cosmic expansion, and the atmospheres of exoplanets. Through these techniques, light becomes a narrative, a story of nuclear fusion, planetary formation, and chemical evolution. The photons arriving at our instruments are, in effect, storytellers from the past, encoding billions of years of cosmic history in subtle variations of wavelength and intensity. Our perception, extended by scientific methodology, transforms this light into comprehension, linking observation, mathematics, and interpretation in an intricate chain of understanding. What we see is never merely what is present. It is an integrated account of processes, history, and context, mediated through light and understood through intellect. Gravity's influence on light also shapes the most profound discoveries in modern cosmology. Gravitational lensing not only magnifies distant galaxies, but allows us to map the distribution of matter in the universe, much of which remains invisible. Dark matter, detectable only through its gravitational effects, bends light and warps space-time, revealing the hidden scaffolding of galaxies. Through this lens, human perception becomes a collaborative effort with the universe. We do not merely look, we interpret distortions, infer structures, and reconstruct realities that are not directly observable. Understanding the cosmos is thus an act of both observation and imagination, requiring the integration of data, theory, and creativity. Perception is elevated from passive reception to active engagement, a dialogue with the universe mediated by light and gravity. Relativity further transforms our understanding of observation. The bending of light, time dilation, and gravitational redshift reveal that the same event may appear differently depending upon the observer's location and motion. Astronomers must correct for these effects, translating distorted signals into accurate models of celestial phenomena. Yet, these corrections are more than technical. They are philosophical. They remind us that perception is inherently contextual, that what is real cannot be divorced from the observer, and that human understanding is always a negotiation between the local and the universal, between finite perspective and infinite expanse. Light and gravity teach that reality is multi-layered, and that comprehension requires both empirical rigor and imaginative flexibility. Light also mediates the perception of motion and change. Through redshift and blueshift, we measure the expansion of the universe, the velocity of galaxies, and the motion of stars within their systems. Light encodes both spatial and temporal dynamics, revealing the unfolding of events on scales far beyond human intuition. Perception, therefore, is not merely a static observation, but a dynamic engagement with processes that occur over millions and billions of years. Every photon carries the signature of motion, energy, and transformation, and by decoding these signatures, humans extend awareness far beyond immediate experience. Light becomes a temporal and spatial bridge, connecting consciousness with the deep, unfolding history of the cosmos. The interplay of light, gravity, and perception has profound implications for philosophy and human cognition. If what we perceive is mediated by space-time curvature, finite speed, and observational context, then knowledge itself is provisional, filtered, and interpretive. Reality is not a single, objective tableau, but a synthesis constructed by the interaction of energy, mass, and consciousness. This insight fosters humility, curiosity, and openness, encouraging humans to embrace uncertainty, to question assumptions, and to explore multiple perspectives. Perception is both a gift and a responsibility. It reveals astonishing truths while demanding careful interpretation, reminding us that understanding the universe is an active, participatory endeavor. The aesthetics of cosmic light, nebulae glowing in ionized gases, the filaments of supernova remnants, the spirals of distant galaxies reveal the universe's capacity for both majesty and comprehension. These phenomena are not only scientifically informative, but emotionally transformative. Observing them engages both cognitive and affective faculties, invoking wonder, inspiration, and a sense of connection with the cosmos. Light becomes a medium through which humans perceive both structure and beauty, knowledge and imagination, demonstrating that perception is as much about emotional resonance as it is about empirical accuracy. The universe communicates through photons, but the human mind interprets these signals through patterns, meaning, and aesthetic appreciation, integrating sensation, reflection, and understanding into a cohesive experience. Gravity's influence on perception extends to subtle effects on the passage of time. Observers in stronger gravitational fields experience time differently than those in weaker fields. Clocks near massive objects tick more slowly, and light emitted from these regions is redshifted. For humans, this relativity challenges intuition. The simultaneity of events is not absolute, and perception is inherently frame-dependent. Awareness of this principle expands both scientific and philosophical understanding, illustrating that perception is contingent, context-sensitive, and relational. Reality is experienced not as a single sequence but as a network of interdependent observations mediated by the fundamental structure of space-time. The human capacity to perceive and interpret light is further enhanced by technological augmentation. Telescopes extend vision across wavelengths invisible to the eye. Radio, infrared, ultraviolet, X-ray, and gamma-ray photons carry unique information about physical processes, energetic events, and matter composition. Instruments transform perception into knowledge, enabling the reconstruction of events billions of years in the past, the detection of planets orbiting distant stars, and the mapping of galactic structures. Perception, augmented by technology, becomes a multidimensional endeavor, synthesizing signals across the electromagnetic spectrum to construct a coherent understanding of phenomena far beyond the reach of unaided senses. Ultimately, light and gravity illuminate the profound entanglement of observation, cognition, and reality. What we perceive is shaped by the behavior of photons, the curvature of space-time, and the interpretive frameworks we employ. Our understanding of the universe emerges from the integration of empirical observation, theoretical insight, and imaginative reasoning. Perception is neither simple nor passive. It is an active, creative, and relational process, linking human consciousness with the vast, dynamic cosmos. Every photon received, every gravitational distortion observed, every spectrum analyzed is a dialogue between the universe and the mind, a collaboration that transforms raw phenomena into comprehension, awe, and inspiration. The study of light and gravity also reframes human perspective on existence. We are observers embedded within a vast, structured, and dynamic cosmos. Our experience of space, time, and matter is mediated by physical laws that are subtle, elegant, and profound. Awareness of these principles cultivates both humility and curiosity. Humility in recognizing the limits of perception, and curiosity in striving to extend knowledge beyond those limits. The act of perceiving the cosmos becomes an ethical and intellectual pursuit, a testament to human creativity, rigor, and imagination. Light and gravity are not merely physical phenomena, they are the instruments through which the universe reveals itself, and through which we cultivate understanding, insight, and wonder. Finally, the exploration of light, gravity, and perception teaches that knowledge is relational, emergent, and participatory. Reality is not merely out there to be observed. It is co-constructed through the interplay of energy, mass, space-time, and consciousness. Human perception is at once limited and extraordinary, capable of extending across billions of light years while constrained by the curvature of space and the finite speed of information. To perceive is to engage, to interpret, and to integrate. Light becomes both medium and message, gravity both constraint and guide, and perception the bridge connecting human consciousness with the cosmos. In contemplating this intricate dance, we are reminded that to observe is to participate, to understand is to wonder, and to perceive is to enter into dialogue with the universe itself. Space travel dreams, motivation beyond Earth. Humanity has always gazed upward, eyes lifted toward the night sky, hearts stirred by the faint glimmer of distant stars. From the earliest mythologies that traced constellations across the heavens to the pioneering telescopes that first resolved planets as worlds, we have been drawn by an irresistible curiosity to explore what lies beyond our immediate surroundings. This impulse is not mere whimsy, it is a fundamental component of human cognition and culture, a drive that has propelled invention, challenged limits, and reshaped civilization itself. The dream of space travel, long imagined in the pages of science fiction, has moved into the domain of reality, fueled by physics, engineering, and an enduring desire to transcend our planetary home. It is in this pursuit, this reaching beyond Earth, that we confront the profound intersection of knowledge, imagination, and human motivation. The aspiration to leave Earth is deeply rooted in both survival and curiosity. From an evolutionary perspective, humans have always migrated, explored, and adapted to new environments. The notion of venturing into space is an extension of these primordial tendencies. It is the drive to explore the unknown, to adapt to new worlds, and to confront challenges that test ingenuity, courage, and collaboration. Space travel is not merely about the mechanics of propulsion or the engineering of life support. It is an expression of the human will, a testament to our capacity to envision and pursue what lies beyond immediate necessity. The desire to journey to other planets, moons, and celestial bodies reflects a fundamental trait: the integration of risk, imagination, and ambition into purposeful action. The technological and logistical challenges of space travel illustrate both human ingenuity and the scale of ambition required. Escape from Earth's gravity well demands immense energy, careful planning, and advanced propulsion systems. The construction of spacecraft capable of sustaining human life over months or years requires mastery of life support, radiation shielding, and closed ecological systems. Navigation through the vacuum of space, where communication delays span minutes to hours and hazards are omnipresent, demands precision, foresight, and flexibility. Each of these challenges highlights the interplay between human cognition, scientific knowledge, and collaborative effort. Space travel is not merely an individual pursuit, it is a collective enterprise requiring the integration of disciplines, technologies, and human creativity in unprecedented ways. Human psychology plays a central role in motivating exploration beyond Earth. Astronauts describe a profound cognitive and emotional response upon leaving the planet. A sense of awe at the fragility of Earth, a perspective of unity in the vastness of space, and an intimate awareness of both vulnerability and resilience. This psychological transformation, often referred to as the overview effect, illustrates that space travel is not solely a physical endeavor, but a cognitive and existential one. Experiencing Earth as a small, isolated sphere suspended in the cosmic void reconfigures priorities, amplifies empathy, and enhances the appreciation for the interconnectedness of life. Motivation to explore space is thus entwined with profound cognitive effects. The desire to witness, understand, and participate in the larger cosmos. The exploration of Mars exemplifies the blend of aspiration, challenge, and imagination that defines space travel. Mars is both familiar and alien. Its day length closely matches Earth's, yet its atmosphere is thin, its temperatures extreme, and its surface scarred by volcanic mountains and impact craters. The scientific potential of Mars, its geologic history, evidence of ancient water, and possible microbial life, has driven decades of robotic exploration and ongoing planning for human missions. Mars is a proving ground, not only for technology but for human resilience, psychology, and adaptability. The dream of setting foot on its surface encapsulates a broader theme. The motivation to explore is inseparable from the desire to extend human presence, knowledge, and culture into new domains. Space travel also challenges our understanding of biology, physiology, and life itself. Humans are adapted to Earth's gravity, atmosphere, and radiation environment. In microgravity, muscles atrophy, bones lose density, and cardiovascular systems undergo profound adaptation. Exposure to cosmic radiation elevates long-term health risks, demanding innovations in shielding, pharmaceuticals, and habitat design. Life support systems must recycle air, water, and nutrients with near-perfect efficiency, creating closed-loop ecological systems that replicate the complexity of Earth's biosphere. These challenges highlight an essential truth: the motivation to explore is inseparable from the need to understand, protect, and sustain life under conditions vastly different from those in which it evolved. Space travel is not only a journey outward, but a deep engagement with the fundamentals of biology, chemistry, and environmental systems. Human culture and imagination are integral to the motivation for space exploration. Science fiction has long served as both inspiration and blueprint, imagining starships, colonies, and interstellar civilization. These narratives do more than entertain. They provide cognitive frameworks for considering human adaptation, ethical dilemmas, and technological possibilities in extreme environments. Fictional visions of space travel allow us to rehearse choices, understand consequences, and expand our sense of what is possible. The interplay between imagination and engineering is dynamic. Ideas conceived in literature inspire experiments, prototypes, and missions, while scientific discoveries refine the narrative landscape, creating a feedback loop between aspiration and achievement. Motivation, in this sense, emerges from the synthesis of intellect, creativity, and the deeply human capacity to envision futures beyond immediate constraints. The economic and geopolitical dimensions of space travel further shape human motivation. Nations and private enterprises invest in exploration to advance scientific knowledge, secure technological leadership, and cultivate strategic advantage. The pursuit of extraterrestrial resources, water, ice, minerals, or energy, offers practical incentives for expansion beyond Earth. Yet even within these pragmatic considerations lies the enduring human drive for discovery. Economic frameworks, policy decisions, and strategic imperatives intersect with curiosity and ambition, demonstrating that the pursuit of space is not a monolithic enterprise but a complex, multidimensional endeavor. Motivation is therefore both intrinsic, rooted in wonder and curiosity, and extrinsic, shaped by societal priorities, technology, and collaboration. The human experience of space travel challenges conventional notions of time, distance, and perspective. Journeys to Mars or the outer planets require months to years of travel, demanding patience, foresight, and psychological preparation. Time becomes a tangible variable. Orbital windows, mission durations, and life support cycles constrain human action, while cosmic distances remind us of our relative minuteness. Spacecraft become microcosms of civilization, testing cooperation, resilience, and the capacity to adapt socially, cognitively, and emotionally. Motivation is sustained not only by scientific objectives but by the vision of achievement, the anticipation of discovery, and the awareness that humans are participating in an endeavor of unprecedented scope and significance. Exploration beyond Earth also prompts reflection on ethics and responsibility. Establishing human presence on other worlds raises questions of planetary protection, environmental stewardship, and the moral implications of altering alien landscapes. Contamination of Mars with terrestrial microbes, the impact of human activity on pristine environments, and the governance of shared extraterrestrial resources challenge our ethical frameworks. Motivation in this context is inseparable from reflection on duty, consequence, and the broader responsibilities of intelligence. Human exploration is not merely about asserting presence, but about exercising foresight, judgment, and care, integrating curiosity with ethical and philosophical consideration. The pursuit of space travel also fosters profound cognitive and technological innovation. Achieving propulsion, energy efficiency, life support, and autonomous decision-making in extreme conditions pushes the boundaries of engineering, robotics, and artificial intelligence. Technologies developed for space often find terrestrial application, enhancing medicine, communications, materials science, and sustainability. The motivation to explore thus extends beyond the immediate goal of reaching other worlds. It drives the evolution of human capability, the expansion of knowledge, and the improvement of life on Earth. The act of striving outward becomes a catalyst for improvement, insight, and collective progress. Motivation to transcend Earth is also fueled by existential reflection. Observing Earth from orbit, astronauts report a profound sense of connectedness and vulnerability, a recognition of the planet's fragility in the cosmic arena. The knowledge that life is rare, delicate and precious, drives both the desire to explore and the imperative to protect. Space travel is simultaneously an act of wonder and stewardship. It expands horizons while reinforcing the uniqueness and preciousness of our home. The human psyche, confronted with the vastness of space, integrates awe, curiosity, and responsibility, translating perspective into purpose and aspiration into action. Human motivation is also informed by collaboration and shared endeavor. Space exploration requires the coordination of multinational team, interdisciplinary knowledge, and sustained commitment over decades. Achievements in space are collective, built upon generations of curiosity, experimentation, and ingenuity. The dream of human presence beyond Earth is thus inseparable from shared vision, a testament to cooperation, mentorship, and the transmission of knowledge. Motivation emerges not only from individual ambition, but from participation in a continuum of exploration, linking past, present, and future through collective endeavor. The dream of interstellar travel, though currently beyond immediate reach, extends motivation into imagination and long-term planning. Concepts such as generation ships, relativistic propulsion, and cryogenic preservation challenge our understanding of biology, physics, and society. They invite contemplation of human adaptability, the nature of civilization, and the ethical dimensions of multi-generational endeavor. The aspiration to traverse stars embodies a commitment to possibility, vision, and resilience, demonstrating that motivation is as much about conceptual expansion as it is about practical achievement. Humanity's imagination, extended into the cosmos, becomes both a guide and a compass, directing inquiry, innovation, and exploration. Furthermore, the motivation to travel beyond Earth is inseparable from the search for understanding and meaning. Space is a laboratory, a stage, and a mirror. It reveals the laws of physics, the history of our solar system, and the delicate conditions that permit life. It challenges our assumptions, expands our comprehension, and encourages reflection on purpose, contingency, potential. Human aspiration to explore space is thus a synthesis of knowledge, curiosity, and existential inquiry. Motivation arises not only from desire to reach distant worlds, but from the deeper human need to situate ourselves within the vast, unfolding narrative of the cosmos. The challenges of space travel, radiation, microgravity, isolation, and resource limitation underscore the extraordinary resilience of human psychology. Training, preparation, and cognitive strategies allow astronauts to function effectively in environments that would be impossible without adaptation. Motivation is sustained by vision, purpose, and connection, the anticipation of discovery, the awareness of contributing to collective knowledge, and the recognition of humanity's shared journey. Space travel is thus a laboratory for human ingenuity, perseverance, and mental fortitude, demonstrating that ambition is both a cognitive and emotional enterprise. Finally, space travel represents the embodiment of possibility. It is the articulation of human curiosity, courage, and creativity into tangible action. Every launch, mission, and milestone expands the horizon of what is achievable, transforming imagination into reality. Motivation to explore beyond Earth is fueled by a recognition of our capacity for innovation, the vast potential of the cosmos, and the profound interconnectedness of knowledge, aspiration, and action. Humanity's dream of traversing space reflects a synthesis of physics, engineering, psychology, and philosophy, a celebration of what it means to reach, to imagine, and to perceive. It is a testament to the human spirit, ever curious, ever striving, and ever compelled to journey beyond the confines of home, toward the infinite possibilities that await in the cosmos. In the final analysis, space travel is not merely the act of moving beyond Earth, it is the crystallization of human motivation in the face of the unknown. It encompasses curiosity, courage, resilience, imagination, ethics, and collaboration. It demonstrates that ambition is inseparable from knowledge, that exploration is entwined with creativity, and that human aspiration is amplified when confronted by the vastness and challenge of the universe. The dream of space travel transforms our perception of what it means to be human, reminding us that we are not bound solely by our terrestrial environment, but are capable of envisioning, preparing for, and inhabiting worlds beyond, propelled by the enduring desire to understand, explore, and participate in the cosmic narrative. 11. Quantum mysteries and the philosophy of uncertainty. At the most fundamental level, the universe is not the solid, predictable place we perceive in daily life. Beneath the surfaces of planets, stars, and galaxies lies a realm governed by rules that defy intuition, where certainty dissolves into probability and observation itself shapes reality. This is the domain of quantum mechanics, a framework so precise and predictive that it underlies modern technology, yet so enigmatic that it continues to challenge our deepest understanding of existence. To engage with quantum mysteries is to confront the limits of knowledge, to explore the boundaries between determinism and randomness, and to grapple with the philosophical implications of a reality in which certainty is never absolute. In this space, science and philosophy converge, revealing the profound interplay between observation, knowledge, and human understanding. Quantum mechanics emerges from the study of phenomena at scales far smaller than atoms. Electrons, photons, and subatomic particles behave in ways that classical physics cannot describe. Particles exhibit duality, behaving both as discrete entities and as waves capable of interference and diffraction. A photon passing through a double slit does not travel along a single, well-defined path. Rather, it manifests as a probability wave, producing patterns that reflect a superposition of possibilities. The act of measurement collapses this wave into a defined outcome, demonstrating that reality at the quantum scale is inherently relational. The observer, the measurement apparatus, and the system are inextricably intertwined. This principle challenges the assumption that the universe exists independently of observation, suggesting that, at its most fundamental level, existence is a web of probabilities rather than a collection of certainties. The uncertainty principle, articulated by Werner Heisenberg, formalizes this limitation. It asserts that certain pairs of physical properties, such as position and momentum, cannot be simultaneously measured with arbitrary precision. The more precisely we know one, the less precisely we can know the other. This is not a limitation of instruments or methodology. It is a fundamental feature of reality itself. At the quantum scale, indeterminacy is built into the fabric of the universe. The recognition of uncertainty reshapes our conception of knowledge. Rather than being absolute and complete, understanding is probabilistic, contextual, and provisional. It teaches humility, demanding that we accept limits while continuing to explore, question, and refine our models of reality. Quantum entanglement amplifies the philosophical implications of these mysteries. Two particles can become entangled such that the state of one instantaneously influences the state of the other, regardless of the distance separating them. This spooky action at a distance, as Einstein famously termed it, challenges classical notions of locality, causality, and separability. Entanglement reveals that information is encoded not solely in individual particles but in the relationships between them, suggesting that reality is fundamentally interconnected. For the human mind, entanglement inspires reflection on the nature of connectedness, interdependence, and the subtle ways in which distant systems can influence one another. It invites a perspective in which the universe is not a collection of isolated objects, but a dynamic relational whole. Superposition, the coexistence of multiple potential states, further deepens the philosophical resonance of quantum mechanics. An electron in a superposed state does not possess a definite position or energy until measured. It exists as a spectrum of possibilities. This principle challenges classical intuitions about reality, prompting reflection on potentiality, choice, and the very nature of existence. If matter itself can exist in multiple states simultaneously, then the distinction between what is and what might be becomes fluid. For humans, this invites an expanded perspective on contingency, decision-making, and imagination. Reality at its core is a landscape of possibilities, and our knowledge navigates this probabilistic terrain with both creativity and rigor. The famous thought experiment of Schrödinger's cat illustrates the tension between classical perception and quantum ambiguity. A cat sealed in a box with a quantum-triggered mechanism is, according to quantum rules, simultaneously alive and dead until observed. While conceived to highlight paradox, the experiment encapsulates profound insights. Observation, context, and measurement are inseparable from the phenomena themselves, and reality at microscopic scales defies simple categorization. For human cognition, the paradox is both unsettling and illuminating. It compels us to question assumptions, to recognize the limits of perception, and to appreciate the subtleties of systems that operate beyond direct sensory experience. In this recognition lies both intellectual humility and philosophical richness. Quantum mechanics is not merely an abstract or academic pursuit, it underpins the technologies that define modern life. Semiconductors, lasers, magnetic resonance imaging, and quantum computing all exploit principles such as superposition, tunneling, and entanglement. These applications illustrate that engagement with uncertainty does not preclude control or utility, rather, it enables unprecedented precision, innovation, and power. The paradox of quantum mechanics is that embracing uncertainty at the fundamental level allows humans to manipulate matter and energy with extraordinary effectiveness. Understanding the universe probabilistically does not limit action, it amplifies it, demonstrating that knowledge, even when incomplete, can be transformative. The philosophical implications of quantum uncertainty extend beyond physics into the nature of knowledge itself. If reality is fundamentally probabilistic, then certainty is a conceptual construct rather than an intrinsic property of the cosmos. Knowledge becomes a map of probabilities, a set of predictive models, and a negotiation between observation, interpretation, and inference. This perspective reshapes epistemology, reminding us that understanding is provisional, that models are tools rather than truths, and that curiosity and critical thinking are essential to navigating the unknown. Quantum mechanics encourages a mindset in which ambiguity is embraced as a space for exploration rather than a source of anxiety. The intersection of quantum mechanics and philosophy also illuminates the role of perception in shaping experience. Classical physics assumes that observation reveals pre-existing properties. Quantum mechanics suggests that observation participates in determining outcomes. Consciousness, measurement, and context are entangled in subtle ways with the phenomena being observed. This has inspired debate, speculation, and reflection on the nature of reality, the limits of human cognition, and the relationship between mind and matter. Whether one interprets this relationality literally or metaphorically, it demonstrates the profound interdependence of observer and observed, highlighting that knowledge is both an external and internal endeavor. Quantum uncertainty also challenges the linear conception of time. In certain interpretations, quantum processes are not bound by a single chronological trajectory. Multiple histories or branching paths may coexist as probabilities until decoherence selects a realized outcome. This resonates with philosophical reflections on temporality. The past, present, and future may be interconnected, flexible, or non-linear at fundamental levels. The exploration of quantum processes encourages a reconsideration of time itself, not merely as a backdrop for events, but as a complex emergent property of physical interactions. For the human psyche, this expands the conceptual horizon, inviting reflection on memory, anticipation, causality, and the structure of experience. The probabilistic nature of quantum events also fosters resilience in human thought. Recognizing that uncertainty is intrinsic to reality encourages flexibility, creativity, and tolerance for ambiguity. Decision-making, problem-solving, and innovation all benefit from an understanding that certainty is provisional and outcomes are often contingent. Quantum mechanics, paradoxically, models the unpredictability of existence while providing tools for prediction, control, and insight. The human mind, engaging with these principles, develops adaptive frameworks for navigating both cosmic and personal uncertainties. Embracing probabilistic reasoning rather than demanding absolute knowledge becomes a source of intellectual and practical strength. Quantum entanglement and non-locality further expand the imagination, inspiring reflection on interconnectedness, causality, and emergent phenomena. The universe is not a set of isolated particles, but a network of correlations, interactions, and relational patterns. Observing one particle informs us about another, distant one, suggesting that boundaries are less rigid than perceived. For humans, this resonates metaphorically and practically. Our actions, choices, and observations are part of larger systems, influencing outcomes in ways that may not be immediately visible. Quantum mechanics, therefore, not only describes subatomic reality, but models relational thinking, interconnected awareness, and the subtle interplay between local action and global consequence. The philosophy of uncertainty derived from quantum mechanics also challenges human notions of control and predictability. In everyday life, we seek causality, stability, and order. At the quantum level, these assumptions dissolve. Randomness, probability, and relationality dominate, illustrating that the universe is inherently complex, nuanced, and probabilistic. This understanding encourages humility, patience, and reflective practice. Rather than diminishing human agency, it frames action as a form of engagement with a dynamic, contingent, and responsive cosmos. Motivation, curiosity, and creativity thrive within this landscape, demonstrating that uncertainty is not limitation but a field of opportunity. Quantum phenomena also inspire technological and conceptual innovation. Quantum computing, for example, leverages superposition and entanglement to perform calculations inconceivable for classical machines. Quantum cryptography exploits the fundamental principles of measurement and uncertainty to secure communication. Even theoretical research into quantum gravity, unifying quantum mechanics with general relativity, pushes the boundaries of mathematics, logic, and imagination. Human engagement with quantum uncertainty exemplifies the integration of knowledge, creativity, and foresight. Confronting the unknown catalyzes understanding, innovation, and progress. The universe, in its indeterminacy, becomes both a teacher and a laboratory for expanding human capability. The contemplation of quantum mysteries also reshapes existential reflection. If the universe is probabilistic, if events are contingent, and if observation participates in reality, then human existence takes on new dimensions of significance and humility. Life, consciousness, and awareness emerge within a universe that is at once structured and fluid, deterministic and uncertain. The human mind navigates these tensions, constructing meaning, making decisions, and engaging creatively with a reality that is profoundly intricate. Quantum uncertainty, far from eroding significance, amplifies the wonder and responsibility inherent in conscious existence. Finally, quantum mechanics invites the mind to expand beyond intuitive limits. It encourages the embrace of paradox, the tolerance for ambiguity, and the cultivation of imaginative reasoning. Observation, measurement, and inference are not merely technical acts. They are cognitive and philosophical exercises, revealing both the capabilities and the limits of human understanding. The study of quantum phenomena fosters a mindset in which uncertainty is recognized as intrinsic, exploration as necessary, and knowledge as dynamic. In engaging with these principles, humans refine not only their comprehension of matter and energy, but also their capacity to navigate complexity, reason creatively, and reflect deeply on the nature of reality. In the final analysis, quantum mysteries illuminate the profound relationship between uncertainty, knowledge, and human perception. They demonstrate that reality is relational, probabilistic, and interconnected, and that observation itself participates in shaping outcomes. They challenge assumptions, expand imagination, and foster cognitive resilience, teaching that understanding is always provisional, contingent, and interpretive. Quantum mechanics reveals a cosmos that is both precise and enigmatic, structured yet indeterminate, inviting humans to navigate the space between certainty and possibility with curiosity, humility, and creativity. To engage with quantum uncertainty is to confront the fundamental nature of existence, to explore the limits of perception, and to recognize that knowledge, imagination, and inquiry are intertwined in the ongoing dance of human understanding with the universe itself. 12. Cosmic silence, contemplation, solitude, and meaning. In the vastness of the cosmos, silence is not merely the absence of sound. It is the profound backdrop against which all existence unfolds. Beyond the confines of our atmosphere, sound cannot propagate, and the universe speaks only in light, gravity, and subtle fields of energy. This cosmic silence, immeasurable and omnipresent, invites contemplation. It compels the human mind to reckon with scale, with solitude, and with the existential resonance of being. To observe the universe is to enter into a dialogue with emptiness, to confront the enormity of space and time, and to find meaning not in noise or immediate gratification, but in reflection, insight, and the delicate harmonies of existence. Cosmic silence is simultaneously humbling and empowering. The vast distances between stars, galaxies, and clusters dwarf human scales of time, space, and experience. When we look at the night sky, even with powerful telescopes, the photons we perceive have traveled millions or billions of years to reach us. We are, in effect, reading messages from the ancient past, encountering events whose echoes persist long after the originating stars have faded or exploded. This realization instills humility, revealing our briefness in the face of cosmic continuity, yet it also empowers the imagination, allowing the mind to traverse epochs, to connect with phenomena far beyond the immediacy of earthbound life. Silence becomes a medium for temporal exploration, a space in which awareness expands beyond ordinary boundaries. Solitude, in this cosmic context, is not loneliness, but an opportunity for profound reflection. The human mind, removed from distractions and immersed in the contemplation of space, can engage with questions of existence, purpose, and interconnectedness. Astronauts describe this experience vividly. Observing Earth as a fragile sphere suspended in the void evokes a sense of unity, fragility, and perspective that reshapes priorities, values, and emotional frameworks. The silence of space externalizes inner reflection, amplifying cognitive and emotional resonance. In this interplay between external stillness and internal awareness, humans discover the capacity for deep insight, creativity, and psychological resilience. Contemplation within the context of cosmic silence fosters a profound recognition of scale. The distances, energies, and timescales of the universe render human concerns both intimate and infinitesimal. Supernovae erupt billions of light years away, gamma-ray bursts flare with energies that defy comprehension, and black holes warp space-time in ways that challenge intuition. These phenomena are indifferent to human existence, yet the mind, observing and understanding them, cultivates a sense of meaning rooted not in control but in perception, interpretation, and reflection. The capacity to contemplate, to absorb the enormity of the cosmos while remaining conscious of our place within it, exemplifies the human ability to derive significance from awareness itself rather than from external dominion. Cosmic silence also invites meditation on temporality. The universe operates on scales far removed from human experience. Stars live for millions to billions of years, galaxies collide over eons, and the expansion of space unfolds imperceptibly, yet inexorably. To perceive these processes is to stretch consciousness beyond ordinary time, situating personal existence within the deep chronology of the cosmos. Solitude enables the mind to consider these scales, fostering perspective, patience, and philosophical reflection. The silence of space is thus a laboratory for thought, a setting in which temporal awareness deepens, priorities recalibrate, and human imagination engages with phenomena that transcend immediacy. Engagement with cosmic silence nurtures existential insight. In a universe largely devoid of life as we know it, the rarity and fragility of conscious existence becomes strikingly apparent. Solitude in this context amplifies awareness of both vulnerability and privilege. Life persists against overwhelming odds. Intelligence emerges within an indifferent cosmos, and consciousness becomes a precious and fleeting phenomenon. Reflection on these truths encourages ethical awareness, responsibility, and a sense of stewardship. The universe's silence challenges assumptions of centrality, dominance, or permanence, inviting humility while simultaneously elevating the significance of conscious agency and creative engagement. The aesthetic dimension of cosmic silence cannot be overstated. Nebulae, supernova remnants, and the spiral arms of galaxies exist in forms of staggering complexity and beauty, visible across the electromagnetic spectrum. Yet their existence is accompanied by profound quietude. These luminous structures emit light and energy, but lack the soundscapes familiar to human experience. Observing these phenomena evokes wonder, introspection, and emotional resonance. Silence becomes a canvas for cognitive and aesthetic appreciation, where observation integrates intellect and emotion, curiosity and reverence. In the absence of auditory distraction, the mind attunes to subtlety, pattern, and scale, cultivating a heightened sensitivity to the interplay between structure and emptiness. The contemplation of silence also encourages philosophical reflection on presence and absence. Just as the void between stars is more than emptiness, containing radiation, dark matter, and the potential for structure, so too are moments of reflection in human consciousness more than idle thought. Solitude amidst cosmic silence allows ideas to crystallize, perceptions to deepen, and connections to form between disparate phenomena. Awareness of absence, paradoxically, illuminates presence. The empty spaces highlight the significance of matter, energy, and life. This interplay between silence and existence becomes a lens through which humans explore meaning, possibility, and relational understanding. Human cognition thrives on patterns, and cosmic silence amplifies the mind's capacity to detect, infer, and imagine. The trajectories of planets, the harmonics of orbital resonance, and the structure of galactic filaments reveal underlying order amidst apparent emptiness. Solitude allows the mind to engage deeply with these patterns, fostering insight, creativity, and problem-solving. Cosmic silence is not a void in which thought ceases, but a fertile environment in which thought can expand, connect, and synthesize across scales, disciplines, and conceptual domains. Observation becomes an act of interpretation, and reflection becomes an exercise in meaning-making. Contemplation of cosmic silence also intersects with the psychology of awe. Awe is a complex emotional state characterized by perception of vastness and a need for accommodation, adjusting mental models to incorporate phenomena that exceed familiar understanding. The silent vastness of space evokes awe, not only through scale but through the interplay of observation, imagination, and reflection. This emotional state has measurable cognitive benefits. It enhances creativity, encourages prosocial behavior, and expands temporal perspective. Solitude in cosmic contemplation magnifies these effects, providing a mental space in which the mind can integrate knowledge, emotion, and philosophical reflection into a coherent, transformative experience. The existential resonance of cosmic silence is further amplified by the recognition of contingency. The universe is not only vast, but largely indifferent. Planetary formation, stellar life cycles, and the emergence of life occur without inherent purpose. Yet human consciousness, embedded within this framework, constructs significance through reflection, creativity, and ethical engagement. Solitude allows the mind to navigate this paradox, reconciling the indifference of the cosmos with the meaningfulness of lived experience. The silent universe becomes both teacher and mirror, prompting reflection on mortality, contingency, and the capacity for agency within an expansive and complex reality. Cosmic silence also fosters intellectual humility. Observing phenomena that span billions of light years manifest energies beyond comprehension and operate according to principles counterintuitive to everyday experience, challenges assumptions of centrality, knowledge, and control. Solitude and reflection, in the presence of these phenomena, cultivate openness to uncertainty, receptivity to new frameworks, and appreciation for the provisional nature of understanding. Knowledge is experienced as a dynamic process, a negotiation between perception, inference, and theory, rather than a static accumulation of facts. Silence provides the mental space to accommodate this complexity, transforming contemplation into wisdom. The interplay between solitude, silence, and relational understanding is profound. Just as stars, galaxies, and cosmic structures are interconnected across space and time, so too are human experiences of reflection embedded within larger networks of culture, knowledge, and legacy. Contemplation of cosmic silence heightens awareness of relationality. The mind recognizes its own participation in systems of thought, observation, and influence that span generations. Solitude is not isolation but integration, a space in which perception, cognition, and imagination align with the larger human enterprise of inquiry, creativity, and understanding. Cosmic silence is also a lens for ethical and philosophical reflection. The awareness of fragility, rarity, and contingency encourages stewardship of life, resources, and knowledge. Solitude in contemplation fosters a sense of responsibility, reminding humans that understanding carries not only cognitive reward, but ethical imperative. The silence of space becomes a reflective medium in which humans evaluate priorities, consider impact, and cultivate a sense of purpose that extends beyond immediate gratification or egoistic pursuit. Through contemplation, silence transforms into a crucible for insight, ethical awareness, and meaningful action. Moreover, the human capacity to derive meaning from silence reflects a fundamental cognitive trait, the ability to synthesize perception, imagination, and reflection. Unlike other species, humans can contemplate scales of time and space that are imperceptible and abstract. Silence provides the scaffolding for such synthesis, allowing cognitive and emotional faculties to integrate observation, insight, and philosophical reflection into a coherent understanding of existence. In this context, cosmic silence is not emptiness, but a medium for human growth, intellectual, emotional, and ethical. Cosmic silence also cultivates resilience. In the face of vastness, unpredictability, and indifference, humans discover the capacity to anchor meaning, to sustain curiosity, and to engage creatively with challenges. Reflection within silence reinforces the understanding that life is both fragile and resilient, contingent and purposeful. Solitude in the cosmic context amplifies these realizations, fostering both psychological and philosophical robustness. The mind, attuned to silence, becomes capable of integrating uncertainty, scale, and temporality, translating observation into insight and isolation into perspective. The aesthetic dimension of contemplation within cosmic silence extends beyond beauty into comprehension. The geometry of spiral galaxies, the delicate interplay of light and shadow in nebulae, and the subtle dynamics of gravitational interactions exemplify elegance, pattern, and coherence. Solitude allows humans to appreciate these patterns, integrating sensory perception with conceptual understanding. Silence is the medium that enables deep attention, facilitating the translation of observation into both aesthetic appreciation and intellectual insight. In perceiving the cosmos this way, humans experience not only knowledge but a profound resonance with the structure and rhythm of existence. Finally, cosmic silence invites the mind to reflect on its own capacities. Awareness of emptiness, scale, and temporal depth prompts inquiry into consciousness, perception, and the human role within the universe. Solitude encourages introspection, ethical evaluation, and imaginative projection. Contemplation transforms silence from an absence into a space of profound engagement, a space in which the mind can traverse epochs, map complexity, and integrate wonder, understanding, and responsibility. In this interplay, meaning is not imposed but co-created, emerging from the interaction of consciousness with the vast silent expanse of the cosmos. In the end, cosmic silence is both a challenge and an invitation. It challenges assumptions of centrality, control, and certainty, and it invites reflection, humility, and imagination. Solitude becomes an instrument for perceiving, understanding, and engaging with the universe at scales and depths far beyond ordinary experience. The silent cosmos offers a mirror in which humans can examine the contours of thought, the patterns of understanding, and the depths of ethical and existential reflection. Meaning is neither imposed by the universe nor absent within it. It emerges through the attentive mind, through reflection, and through the courage to confront both the immensity of the cosmos and the subtleties of inner awareness. Cosmic silence teaches that contemplation is not passive. It is active, participatory, and transformative. In solitude, humans develop the capacity to integrate observation, understanding, and philosophical reflection, translating the emptiness of space into the fullness of insight. Silence becomes a bridge between the finite and the infinite, the temporal and the eternal, the individual and the cosmic. It cultivates curiosity, empathy, and resilience, encouraging humans to approach existence with both humility and wonder. The cosmos, vast and silent, becomes not a void to fear, but a canvas upon which thought, perception, and imagination converge, generating understanding, meaning, and inspiration. In embracing cosmic silence, humans confront not only the universe, but themselves. They recognize fragility, agency, and interconnectedness. They discover that meaning is not granted by scale, magnitude, or certainty, but emerges from attentive observation, reflective thought, and ethical imagination. Solitude in the context of cosmic contemplation amplifies cognitive and emotional capacities, creating space for synthesis, insight, and the emergence of profound understanding. The silent universe, in its immensity and indifference, becomes both a teacher and a mirror, inviting humans to consider existence, purpose, and possibility at scales and depths that challenge perception, yet expand the mind. Ultimately, cosmic silence is the arena in which contemplation, solitude, and meaning converge. It is the stillness in which awareness deepens, imagination expands, and understanding crystallizes. It is in this quiet expanse that humans find perspective, cultivate insight, and discover resonance with the vast unfolding story of the cosmos. Silence is not absence, it is presence, the presence of time, space, energy, and the reflective mind. In engaging with this profound stillness, humans encounter both the universe and themselves, forging a relationship that is at once intellectual, emotional, and existential, and discovering that within silence lies the potential for knowledge, wisdom, and the deepest forms of meaning.